Yeah. Sure, I can do that. Clear. Yesterday we started with which topic? Okay. Clouds ನೋಡಿದ್ರ ಡಿಫರೆನ್ಶಿಯೇಟ್ ಮಾಡಕ್ಕೆ ಗೊತ್ತಾಗತ್ತಾ ಬಟ್ ಸ್ಟ್ರಾಟಸ್ ಕ್ಯುಮುಲಸ್ ನಿಂಬಸ್ ನಿಂಬಸ್ ಸಿಗಲ್ಲ ಇವಾಗ ಅದು ರೈನ್ ಸೀಸನ್ ಮಾತ್ರ ಸಿಗುತ್ತೆ ನೋಡೋಕ್ಕೆ ಬೇರೆ ನೋಡಿಲ್ಲ ಇವತ್ತು ನೋಡಿ ಹಿಂದೆ ಬೆಳುವಾಗಲೇ ಕತ್ಲೆ ಕ್ಲೌಡಲ್ಲಿ ಅಲ್ವಾ then what we discussed heat budget. What is the source for the atmospheric temperature? What is the maximum source for the atmospheric temperature? Earth radiation, not solar radiation. Solar radiation is only for 14% and 34-35% is from the earth. Okay. Now we feel like yes, it is through solar radiation. No, actually earth radiation is also a solar radiation. There is a reflection from the albedo of the earth, right? And they are getting as a types of rain. Again, we can discuss part on that. This is also orographic discuss ಮಾಡಿದ್ರಿಂದ clouds precipitation discuss ಮಾಡಿದ್ರಿಂದ ಸ್ವಲ್ಪ not two types of rainfall ಇದೆ. Types of rainfall. Types. First one is convectional rainfall. What is convection? What is convection? What is convection? That's it. Whenever due to high temperature, think about it. Whenever due to high temperature, or near low pressure areas, we observe air rising vertically. And moisture condenses to form cumulus or cumulonimbus, cumulus cumulus or cumulonimbus. Cumulus is one kind of cloud. Nimbus is another kind of cloud. This is a hybrid. Cumulonimbus cloud. Okay. And provide rainfall along with thunderstorm. That's a disturbance. And provide rainfall along with thunderstorms. Data. Last week thunderstorms and lightning is conventional rainfall. Right? Yesterday we discussed about this. Second one, orographic. This is new for you. Orographic rainfall. What is orographic? Orographic. See, something oro means what? Orographic. It is related to mountain. Okay. Normally, consider this as a mountain. This is called windward side. Windward side means the side which winds are blowing. Like if the wind is like this is called windward side, and this is called leeward side. Leeward side. The wind is blowing from here and descending from here. This descending side is called leeward side, and the wind blowing side is called windward side. Normally, when the wind blows like this and mountains stand like this, because of this mountain, wind tends to go higher altitude. When they tends to go higher altitudes, they condenses there because of normal lapsing rate. Yesterday we discussed normal lapsing rate. Means 6.5 degrees Celsius temperature decreases per kilometer. That is what normal lapsing rate. Because of this mountain, these winds tend to go higher altitude. Because of normal lapsing rate, that wind condenses to form the clouds. And clouds are in the windward side of the mountains. Majority of the clouds are in the windward side of the mountains, not on the leeward side of the mountains. Each area, windward side of clouds are. So that the windward side of the mountain experiences heavy rainfall, and the leeward side of the mountain experiences drought or no rainfall. And the heat winds, like this is the moisture with winds, right? This is the moist wind, and this is the dry wind, because the moisture which is there in the wind are condensed to form the cloud. So rest is dry wind which descends from here. So leeward side experiences drought normally, and windward side experiences flood normally. Okay, this is all. And this cloud, because of this cloud, this area experiences rainfall, right? Precipitation, right? This kind of rainfall is called orographic rainfall. Because of this means because of this mountain, rainfall experiences in the windward side of the mountain. This kind of rainfall is called orographic rainfall. Okay. First write this diagram, then I'll dictate. Look at Karnataka only. Agumbe, Chikmagalur, Dakshin Kannada. This area receives high rainfall compared to North Karnataka or central part of Karnataka, because these area are the windward side of the Western Ghat. If you consider Western Ghat as an entire mountain, this area, the clouds, the wind which is blowing from this ocean, this sea, Arabian Sea, which blocks by the Western Ghat, and the clouds form in the windward side of the Western Ghat, like these districts. Shimoga, Dakshin Kannada, Udupi. So that Agumbe experiences heavy rainfall in Karnataka, and North Karnataka experiences every year drought kind of, or heat waves kind of situation. That is the geographic reason. Like in Andhra Pradesh, there is a place called Rayalaseema. Rayalaseema is Bailseema in Kerala. That is Andhra Pradesh, Rayalaseema. That is a drought area, dry area. That is also because of Eastern Ghat, leeward side. Eastern Ghat, leeward side. This is South India area. ಇಲ್ಲಿ Western Ghat ಬರ್ತಲ್ಲ, ಇಲ್ಲಿ Eastern Ghat ಬರ್ತಲ್ಲ. Eastern Ghat leeward, this is the windward side, because Bay of Bengal ಇಂದ ಬಂದಿರೋ winds ಇಲ್ಲಿ leeward side ಆಗುತ್ತೆ. And this is precipitation area, and this is dry area because of dry winds. So this is Rayalaseema of Andhra Pradesh. ಇದು ಬಯಲುಸೀಮೆ ಅಂತ ಕರಿತೀವಿ ನಾವು ಈಚೆಲ್ಲ precipitation ಜಾಸ್ತಿ. ಆಗುಂಬೆ, ದಕ್ಷಿಣ ಕನ್ನಡ, ಶಿವಮೊಗ್ಗ ಮಲೆನಾಡು. Wind blowing towards a mountain, rises on the windward side towards mountain, rises on the windward side and condenses to form cloud. Condenses to form cloud. Once the air descends the mountain, once the air descends the mountain, once the air descends the mountain on the leeward side, temperature increases and does not give rainfall. Rainfall associated with mountains, rainfall associated with mountains are known as orographic rainfall. Are known as orographic rainfall. And it is usually observed that windward side would be moist. Windward side would be moist, and leeward side would be dry. Leeward side would be dry. There is another kind of rainfall called cyclonic rainfall that I will do it in a cyclone shop. We are doing cyclone. Take heading as that local winds. Some of the local winds are very accurate for UPS. Now and then there is local wind is it? What is local wind? Local means vocal for local. Same thing. Local winds. Okay. First one, Sirocco. Sirocco. Sirocco is one of the local wind that we experience in northern Africa, Mediterranean Sea, and Europe. If you look at the map of world map, ನೋಡಿ ಅದರಲ್ಲಿ ಆಫ್ರಿಕಾ ಮೇಲೆ ಮೆಡಿಟರೇನಿಯನ್ ಸಿ ಬರುತ್ತೆ, ಅದರಿಂದ ಮೇಲೆ ಯುರೋಪ್ ಬರುತ್ತೆ. ಆಫ್ರಿಕಾದಲ್ಲಿ ಮಿಡ್ಲ್ ಅಲ್ಲಿ ಇದೆ ಅಲ್ವಾ, ದಟ್ ಸೈಡ್ ಎಲ್ಲೋ ಇರೋದು ಆಸ್ಟ್ರೇಲಿಯಾ, ಎಕ್ಸ್ಟ್ರೀಮ್ ಲೆಫ್ಟ್ ಇರೋದು USA, ಇನ್ ಬಿಟ್ವೀನ್ ಇದೆಯಲ್ಲ ಆಸ್ಟ್ರೇಲಿಯಾ ಇನ್ ಬಿಟ್ವೀನ್ ಇರೋದು ಆಫ್ರಿಕಾ ಮೇಲೆ ಮೆಡಿಟರೇನಿಯನ್ ಸಿ ಬರುತ್ತೆ, ಮೆಡಿಟರೇನಿಯನ್ ಸಿ ಮೇಲೆ ಯುರೋಪ್ ಬರುತ್ತೆ. ಸಹಾರಾ ಡೆಸರ್ಟ್ ಎಲ್ಲಿ ಬರುತ್ತೆ? ನಾವು ವಿಚ್ ಕಾಂಟಿನೆಂಟ್? ಸಹಾರಾ ಡೆಸರ್ಟ್, Sahara, Africa. In Africa, eastern, western, northern, southern. Delhi. Not South Africa. It's in northern. Okay. Like, if you consider this is Africa, just imagine this is Africa, and this is the Mediterranean Sea, and this is Europe. This is Mediterranean Sea. This is Africa. This is Sahara Desert. Sahara Desert. The wind which starts from here, Sahara Desert, and blow towards north side, and it took some moisture in the Mediterranean Sea. Like Mediterranean Sea ಮೇಲೆ evaporate ಆಗಿ ಹೋಗ್ತಾ ಇರುತ್ತಲ್ಲ, ಅಲ್ಲಿಂದ moisture absorb ಮಾಡ್ಬಿಡುತ್ತೆ. And these winds reaches to Europe, the wind which blows from the desert, it carries some sand. Sand normally red color, right? Like soil content, red color. And the moisture is from the Mediterranean Sea. And it going to give a rain in Europe. And the rain color is red because of this sand of this Sahara desert. That's why this kind of rain is called blood rain, because somewhat red in color because of this Sahara desert. That's why the name blood rain, or this wind is called sirop. Moisture from Mediterranean Sea and that red colored particle from the Sahara desert. Okay. A diagram I am not supposed. Winds or everybody right must right. Winds blowing from Sahara desert to Europe. Through Mediterranean Sea. Receives red sand from Sahara. And moisture from Mediterranean Sea. Red sand from Sahara and moisture from Mediterranean Sea. And provide blood rain in Europe. Blood rain in Europe. Okay. What? Take second one. This is Africa. Where is India? Eastern side or western side? Eastern side. Around. What is the ocean here? Indian Ocean. Here? Atlantic or Pacific? Atlantic Ocean. Pacific here. Here it is South America. After this, Pacific Ocean. See, this is the region. Consider this region. Normally, what is sea breeze? Yesterday we discussed what is sea breeze. Exactly, the wind which blow from the sea towards land. It's a kind of onshore wind or a sea breeze. Means ಇಲ್ಲಿಂದ start ಆಗಿ ಇಲ್ಲಿಗೆ ಬರುತ್ತೆ. So ಇಲ್ಲಿಂದ start ಆಗಿ ಇಲ್ಲಿಗೆ ಬರುತ್ತೆ. The wind which is starting from the water body and moving towards the land or continent means what? It receives some moisture, right? It brings some moisture because it arises from the water body. When it arises from the water body, it brings some moisture means there is a wet kind of situation here, right? Normally there is a wet kind of situation. Because of this every time wet, the people who reside in this region experiences cough or fever, this kind of like ಯಾವಾಗಲೂ ಮಳೆಗಾಲ ಆದರೆ ಸೊ ಯಾವಾಗಲೂ ನೀರು ಜಾಸ್ತಿ ಅಂದ್ರೆ ವೆಟ್ ಇದ್ರೆ ಏನಾಗುತ್ತೆ some health issues ಬಂದೇ ಬರುತ್ತೆ and these people experiences every time health issues and the wind which is blowing from Sahara desert towards Atlantic Ocean. This is offshore wind, right? Or onshore, this is offshore wind. The wind which is from the continent to water, yesterday we discussed, to from the continent to first listen this, right? Yesterday we discussed it. Offshore wind or land breeze. Land breeze means what? Land to sea. When the wind arising from the land and which is moving towards the sea means, is it dry wind or wet wind? Dry wind. So this land breeze gives some dry kind of exposure to the peoples of this region. Here they are already suffering from so many diseases, so many health issues because of this wet, and this acts as a treatment or medicine for those ill health. So because of this reason, these winds are called doctor's wind or hermeton. This is second local wind, doctor wind, doctor's wind. And the hermeton. Hermeton. This is another kind of local wind. Because of this continuous sea breezes, there is some health issues on the western side of Africa, and the wind which starts from the Sahara Desert, that is land breeze, which acts as a medicine or something. It's a curative agent. That's why the name itself is doctor's wind. It cures the illness, right? That's why the name doctor. So this is second local wind. In the western part of Africa, humidity increases. Due to onshore winds. Humidity increases due to onshore winds from Atlantic Ocean. Due to this, people in the region face health issues. Dry winds blowing from Sahara reduces humidity. Dry winds blowing from Sahara reduces humidity and cure several diseases. Sahara Desert and Western continent local winds. African continent local winds. What is this continent? Is it South America or North America? North America. Consider this as a North America. Okay. Rocky Mountain. Rocky Mountain. Here is the Rocky Mountain and is Rocky. Rocky Mountain on the western side of North America. Okay. And what is the ocean here? Pacific. Okay. Normally, this is North America means it is near the pole, right? Near the pole in Earth, equator 60 degree, pole 90 degree. And I told you yesterday, in pole, always cold region. Both the pole, Arctic and Antarctic region, very cold. And because of that cold, this experiences snowfall. Every year snowfall. And in all seasons it experiences snowfall. So wheat cultivation is very difficult here. But their main food is wheat. And the wind which blow from Pacific Ocean. And because of this mountain, this is kind of orographic. And cloud forms here and rainfall here. This is the windward side, right? And what happens in the leeward side? Dry wind. Dry wind which descends from the Rocky Mountain acts as a heater for this region and the snow covered area, that go, and a normal, stable environment set up there, so that it will help for wheat cultivation. And that's why this local wheat is famous, and the name itself is Chinook. Chinook means something favor or something, good and Chinook. This is good for farmers, right? Chinook. The wheat name itself, Chinook. This is Rocky Mountain, okay? Rocky Mountain. Snow eater anta sametha kartare. Snow eater, because it eats snow, or it acts as a eater. So that would help for wheat cultivation in the eastern part of America. North America. Chinook or snow eater. Chinook, snow eater, fawn. FOEHN, another name, fawn. These are very important for MPSC and KPSC. So many times they are even in the prelims and in the mains. These are very important winds, local winds. Take a note. During winter season, North America are under snow cover. Snow cover. Winds descending from Rocky Mountain. Winds descending from Rocky Mountain could be warmer. Could be warmer. And when they blow over snow-covered area, they remove snow completely. And helps in wheat cultivation. Where California located? California located. California located. North America, first of all, and then to this side, left side of Rocky Mountain or western side of Rocky Mountain, California. Okay. See. If the wind starts from here, that is a wet winds, right? Because this is a Pacific Ocean. If the wind starts from here, that is dry wind, because it starts from the continent. There is no moisture. Here there is a moisture, that's why here rainfall, here dry wind. The wind which comes from here is, this side is also, windward side also, there is no cloud. And leeward side, very hot, because it arising from the continent, not on the ocean, right? So the very dry wind which descends from here, like this side there is no cloud because of it is a continental wind or offshore wind, or it is not a land, this is not a ocean breeze or sea breeze, this is a land breeze. That's why there is no cloud here. If there is no cloud here, means here very hot, descending here. When the hot air descends here, there are some trees. You know, Christmas tree ಬರುತ್ತವ ಆ ಥರದ ಟ್ರೀಸ್ ಇರುತ್ತೆ ಎಲ್ಲಿ ಕ್ಯಾಲಿಫೋರ್ನಿಯಾ ರೀಜನ್ ಅಲ್ಲಿ. ಆ್ಯಂಡ್ ಅದರಲ್ಲಿ ತುಂಬ ಇದೇನಂದ್ರೆ ಲೀವ್ಸ್ ಎಲ್ಲ ಇದಿರಲ್ಲ, like ಗಟ್ಟಿ ಸರ್ ಆ್ಯಂಡ್ ಇನ್ ದಿ ಸಮ್ಮರ್ ಆ ಗಟ್ಟಿ ಸಮೇತ ಇರಲ್ಲ ಲೈಕ್ ಗ್ರೀನರಿನೇ ಇರೋದು ಫುಲ್ ಡ್ರೈ when it is full dry the dry winds which descending from here that make these trees to shake like this tree start to vibrate because of this speedy wind when it start to vibrate it sets fire. So there is every year bush fire or forest fire in California region because of this offshore wind or because of this land breeze. So this is called because of this forest fire. This wind is called Santa Ana. Santa Ana means something forest fire. Santa Ana. Two different words. Santa Ana. This is another kind of local wind. The wind which are rising from western part of, eastern part of North America, that is a land breeze, not ocean breeze. The land breeze means it is dry only, even in the windward side. In the leeward side, very dry, and while descending, it sets fire for the existing dry trees in the California region. Because of this wind, California region every year experiences forest fire. Because of these qualities of this wind, it calls as it gets its name as a Santa Ana. Okay. In California region during summer season, we do not observe much rainfall and trees shed their leaves. We do not observe much rainfall and trees shed their leaves, become dry. Winds descending from rocky mountains. Winds descending from rocky mountains blow over this region. They lead to forest fire. Okay. So North America only. Where is Canada? Where is Canada located? Canada. This is Canada and this is US. This is Canada. This is Canada. This is US and this is Mexico. Right? What is this ocean? Indian Ocean, Atlantic. He said Pacific. See, consider there is high temperature in the Atlantic. When there is a high temperature, what happens to pressure? Low pressure. And when here it is low pressure, comparatively here high pressure. Okay. High pressure in Canada, and in Canada's winter what happens? Very low temperature because normally it is in the location itself it is situated towards the pole. When it is towards the pole means normally very low temperature. In a winter means snow covered. Snow covered means very low temperature. When very low temperature, high pressure is at its peak means very high pressure. Very low temperature means very high pressure, right? Very high pressure, and here it is in the Atlantic Ocean, low pressure. Wind always blow from high pressure to low pressure, right? Wind always blow from high pressure to low pressure. Along with this wind, the snow-covered region, here it is snow-covered region, right? the snow are also come with the wind. And these snow from the Canada, see this is USA part, right? This is part of USA. They come over USA. In USA there is no snow cover, or there is no snowfall. And because of this wind, USA, northeastern part of USA experiences snowfall. Because of this wind, northeastern part of USA experiences snowfall. So that because of this snowfall causing reason, this wind is called blizzard. Blizzard means something snow. Blizzard. Because of these characteristics of this wind is called blizzard. Just write diagram, I think. Not scientific. Write diagram. For during winter season, see why only we experience this in the winter? Why not in the summer? In winter, there is high low temperature. It's very low temperature. Very low temperature always associated with very high pressure. Because of this pressure differences only, this wind will blow. Otherwise, wind will not blow. Very high pressure to low pressure area. In the Atlantic Ocean, low pressure area comparatively, and in the North America, very high. I mean Canada, very high pressure in winter. And there is a snow-covered area in winter. In summer, there is a snow, but the intensity of the snow is very less. In winter, the intensity is very high. Because of that, and because of the pressure differences, there is a blow. So we must mention this winter season. Otherwise, this answer feels like incomplete. During winter season, Canada will be under high pressure. And normally it is associated with snowfall. Atlantic Ocean would be warmer. And winds blowing from Canada to Atlantic. Gives snowfall in northeastern US. The winds blowing from Canada to Atlantic gives snowfall in northeast US. Local winds kada. These local winds. Either local winds ತುಂಬಾ ಕಡೆ ಇದೆ. ಇಂಡಿಯಾದಲ್ಲೂ ತುಂಬಾ ಬರುತ್ತೆ. Like ಕೇರಳದಲ್ಲಿ ಒಂದು ವಿಂಡ್ ಇದೆ ಗೊತ್ತಿದೆ ನಿಮಗೆ. ಮ್ಯಾಂಗೋ ಶವರ್ಸ್ ಅಂತ ಕರೀತಾರೆ. What is that? Winter rainfall ಆಗುತ್ತೆ. Normally India experiences rainfall in summer, June. However, there is no only 2 seasons. There is no rainy season in India. Why only 2 seasons? Yesterday we gave a proof like northern hemisphere, southern hemisphere, summer, winter, and southern hemisphere experiences extreme temperature, extreme summer, extreme winter, and northern hemisphere experiences mild summer, mild winter. That's why there is a life on the northern hemisphere. Every continent or every life, our majority of our population in the northern hemisphere, which is suitable for the life. Right? Take latitude as a heading, not latitude, longitude. Now, in ಸ್ವಲ್ಪ ನೋಡಿದ್ವಿ ಇದ್ರ ಬಗ್ಗೆ ಎಲ್ಲ ಅಲ್ವಾ? Latitude. ಫಿಲಿಮ್ಸ್ ಕ್ವಶನ್ ಬರೋದಕ್ಕೆ ತುಂಬಾ ಈಸಿ ಇರುತ್ತೆ, ಆದ್ರೂ ತಪ್ಪು ಮಾಡ್ತಾರೆ. ಹೌ ಮೆನಿ ಲ್ಯಾಟಿಟ್ಯೂಡ್ಸ್ ಆರ್ ದೇರ್? ಆಕ್ಚುಲಿ ಅರ್ಥಲ್ಲಿ ನಾವು ಸುಮ್ಮನೆ ನೋಡಿದ್ರೆ ಬೈ ನೇಚರ್ ಏನಾದ್ರು ಲ್ಯಾಟಿಟ್ಯೂಡ್ಸ್ ಇದೆಯಾ? ಫಾರ್ ಅವರ್ ಕನ್ವೀನಿಯನ್ಸ್, ನಮಗೆ ಲೊಕೇಟ್ ಮಾಡೋದಕ್ಕಾಗಿ ಜಿಯೋಗ್ರಫಿಕಲ್ ರೀಸನಿಗಾಗಿ ನಾವು ಲ್ಯಾಟಿಟ್ಯೂಡ್ ಮಾಡ್ಕೊಂಡಿರೋದು. ಬೈ ಅರ್ಥಲ್ಲಿ ಏನೋ ಲ್ಯಾಟಿಟ್ಯೂಡ್ ಇಲ್ಲ. ದಿಸ್ ಇಸ್ ಫಸ್ಟ್ ಯು ಮಸ್ಟ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್. ಅಂಡ್ ಹೌ ಮೆನಿ ಲ್ಯಾಟಿಟ್ಯೂಡ್ಸ್ ಆರ್ ದೇರ್? Consider this is a which latitude is it? This is 0 degree latitude, right? ಅಕ್ಷಾಂಶ ರೇಖಾಂಶ 0 degree latitude. ಅದೇ ತರ ಎಷ್ಟು ಲ್ಯಾಟಿಟ್ಯೂಡ್ ಇದೆ ಹೇಳ್ತಾರೆ. Total how many latitudes are there? 23.5 degree ಇದೆ. Tropic of Cancer. ನಿನ್ನೆ ಮಾತಾಡ್ತೀವಿ 23.5 degree ನಾರ್ತ್ ಸೌತ್ ಅಲ್ಲಿ Tropic of Capricorn. ಅದೇ ತರ 10 degree, 15 degree, 60 degree, right? 30 degree, 60 degree, 45 degree, 60 degree, 90 degree pole, right? 90 degree, 0 to 90 degree, and 0 to here also 90 degree. Then how many latitudes are there on our Earth? 1 degree means 1 latitude. Now tell me. 1 degree means 1 latitude. How many latitudes are there? See, this is 0 degree, alva? 1 degree, 2 degree, 3 degree, till 90 degree means 90 latitude. Here it is 90. So how many latitudes are there overall? 181, because 0 degree latitude is also one kind of latitude. Normally 180 anta heltare, that is wrong. So go for option 181. Take a note. There are 181 latitudes. And they are called parallels. Parallel. Why they are called parallels? Because they are parallel. What is parallel? Parallel something. Parallel meaning. Parallel. This is symbol. Parallel. What is this? It never ever intersect. Never. ನೀವು ಎಷ್ಟು ದೂರ ಬೇಕಾದ್ರೆ ಡ್ರಾ ಮಾಡಿ intersect ಆಗಲ್ಲ. That is called parallel. And all latitudes are the parallels. All longitudes are parallels. This is the latitude, okay? Yes? Okay. If you look at this distance and this distance, hege longitude nಮ್ದು latitudes are parallels. Hege look at this distance and this distance. Parallels means what? Between distance should be same. Wherever you draw, the in between distance should be same, alva? Distance same idea. So longitudes are not parallels. Only latitudes are parallels. And what is the distance between two latitudes? 111 kilometer. 111 kilometer. Two latitudes. The distance between two latitudes is 111 kilometer. Is 0 degree ಮತ್ತೆ 1 degree ಇದೆಯಲ್ಲ? Consider this as 1 degree. This is a 2 degree. This is 111 kilometer. And on the equator, the distance between two longitude is also 111 kilometer. This is only on the equator. This is called 0 degree is called equator. 0 degree is equator. On the equator or on the 0 degree only, the longitudes are 111 kilometer. And rest of the area, this is less than 111 kilometer, right? ಕಮ್ಮಿ ಇರುತ್ತೆ ಇದಕ್ಕಿಂತ. The distance between two longitude. The distance between two longitude on the equator is 111 kilometer. And the distance between two longitude, maybe in the north side or maybe in the south side, is less than 111 kilometer. And the distance between two longitude in the pole, distance between two longitude in the pole 0 degree. I mean 0. ಅದೆಲ್ಲ ಬರುತ್ತೆ. The distance between two longitude at pole is 0 kilometer. And the equator is also known as great circle. Equator is also known as great circle. Why call it as a great circle? Why we call it as a great circle? Why not 1 degree, 2 degree, latitude? Great circle. See, only 0 degree latitude or equator cuts the earth into two halves, two equal halves. Only 0 degree latitude cuts the earth into two equal halves. ಇದು ಮಾತ್ರ ಅಲ್ವಾ 1 ಡಿಗ್ರಿ ಮಾಡಿದಾಗ ನಾರ್ತ್ ಸೈಡ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. 1 ಡಿಗ್ರಿ ನಾವು ಡಿವೈಡ್ ಮಾಡಿದ್ರೆ 2 ಡಿಗ್ರಿ ಈ ಸೈಡ್ ಮಾಡಿದ್ರೆ ಸೌತ್ ಸೈಡ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಸೊ ಓನ್ಲಿ 0 ಡಿಗ್ರಿ ಆರ್ equator cuts the earth into two equal halves or divides the earth into two equal halves. If you talk about longitude, every longitude is big circle. Means every longitude divides the earth into two equal halves. ಅಲ್ವಾ? ಈಗ ನೀವು 3 ನನ್ನ ಹತ್ರ ಗ್ಲೋಬ್ ಇಲ್ಲ ಇದ್ರೆ ತೋರಿಸ್ತಾರೆ. ನೀವು 3D ಅಲ್ಲಿ ಇಮ್ಯಾಜಿನ್ ಮಾಡಿ. 3D ಅಲ್ಲಿ every longitude cuts the earth into or divides the earth into two equal halves. But latitude ಅಲ್ಲಿ ಇಲ್ಲ. ಇಲ್ಲಿ ಬಂದಾಗ latitude ಚಿಕ್ಕದಾಗುತ್ತಲ್ವಾ? ಇಲ್ಲಿ this is the, if you consider this as the 89th latitude, 89 degree, this is the length. Equator is length. Alright? So only equator cuts the, or if the question is like no latitude cuts the earth into two equal halves, wrong, because equator cuts. And if the option is like question is that every longitude divides the earth into two equal halves, right? Every longitude. And the length of latitude is not same, and the length of longitude is same everywhere. I mean, length of every longitude is same. Length of this length is also same, this length is also same, this length is also same. But this is lengthier than this, right? So length of longitude is differs. Sorry, length of latitude is differs. Length of longitude are same. ಇದೆಲ್ಲ ಪ್ರೈಮರಿ ಇದು, ಆದ್ರೆ ನಾವು ಎಕ್ಸಾಮ್ ತಪ್ಪು ಮಾಡ್ತೀವಿ. ಲೆಂತ್ ಆಫ್ ಲಾಂಗಿಟ್ಯೂಡ್ಸ್ ಆರ್ ಸೇಮ್ ಅಲ್ವಾ? ಇಲ್ಲಿಂದ ಇಲ್ಲಿವರೆಗೆ ಎಲ್ಲ ಲಾಂಗಿಟ್ಯೂಡ್ಗಳು ಏನು ಡಿಫರೆನ್ಸ್ ಇಲ್ಲ. ಬಟ್ ಲ್ಯಾಟಿಟ್ಯೂಡ್ ಅಲ್ಲಿ ಡಿಫರೆನ್ಸ್ ಇದೆ. 0 ಡಿಗ್ರಿ ಲೆಂತಿಯರ್, 90 ಡಿಗ್ರಿ ವೆರಿ ಶಾರ್ಟ್ ಆರ್ 0 ಹಾಗೆ. ದಿಸ್ ಇಸ್ ಹೌ. And latitude runs west to east direction and divides the earth into east and west, right? Is my statement right or wrong? Latitude runs east to west direction or west to east direction and it divides the earth into north and south, right? Latitude runs east to west direction and divides or give north-south direction. So which gives north-south direction? Not longitude. ನಮಗೆ ಅನ್ಸುತ್ತೆ longitude may be north-south direction ಕೊಡುತ್ತೆ ಅನ್ಸುತ್ತೆ. ಇಲ್ಲ. Latitude runs east-west but gives north-south direction. Not longitude. Longitude gives east-west direction. Runs north-south and gives east-west direction. Longitude gives east-west direction. If we move from pole to, equator to pole, the distance between two longitude decreases or not? If we move from equator to pole, the distance between two longitude decreases. What problem? Move from equator to pole, the distance between two longitude decreases. If we move from equator to pole, the distance between two latitude decreases? No. The distance between two latitude never change. Wherever you go, the distance between two latitude never change. But the length between two latitudes decreases. See, when we move from equator to pole, distance between two longitude decreases. When we move from equator to pole, length between two decreases. If you move from equator to pole, distance between two longitude decreases. If you move from equator to pole, distance between two latitude decreases. The length between, not distance, the length between two latitude decreases, not distance. The length for latitude, distance for longitude. Distance decreases in between the longitude, length decreases in between the latitude. This is the point. Simple concept, all mistake ಆಗುತ್ತೆ. So international date line, international timeline, is it a longitude concept or latitude concept? Longitude, 0 degree longitude is international timeline. 180 degree longitude or international date line. 0 degree longitude or international timeline and 180 degree longitude or international date line. And another very important thing here is, on equator, wherever you go on equator, from here to here, the countries which is there on equator, the day and night length of day and night is on an average similar in every season. On an average, there is less, disturbances. On an average, it will be same. But if you go to pole, summer means extreme summer, means the daytime is lengthier during summer and night time is lengthier during winter in both the poles. In both the poles, here long summers means the daytime is lengthier during summer and night time is lengthier during winter. In equator, there is no like that. In every season, similar. There is less distractions. But in the pole, daytime is lengthier during summer in both the poles, north and south. Daytime is lengthier during summer, and our day length increases during summer, and night length increases during winter. When we go from equator towards pole, the day length increases. ಇದೆಲ್ಲ ತುಂಬ ಇಂಡೈರೆಕ್ಟ್ ಆಗಿ ಹೇಳ್ತಾರೆ ನಿಮಗೆ. ಲೈಕ್ ಇಲ್ಲೊಂದು ಯಾವ್ದು ಈಕ್ವೇಟರ್ ಮೇಲೆ ಒಂದು ಕಂಟ್ರಿ ಕೊಡ್ತಾರೆ, ಪೋಲ್ ಇರೋದು ಒಂದು ಕಂಟ್ರಿ ಕೊಡ್ತಾರೆ. ಓಕೆ, ಸ್ಕ್ಯಾಂಡಿನೇವಿಯನ್ ಕಂಟ್ರಿ, ಯಾವುದೋ ಒಂದು ಸ್ಕ್ಯಾಂಡಿನೇವಿಯನ್ ಕಂಟ್ರಿ ಪೋಲ್ ಇರೋದು ಎಕ್ಸಾಂಪಲ್ ಕೊಡ್ತಾರೆ, ಮತ್ತೆ ಈಕ್ವೇಟರ್ ಮೇಲೆ ಇರೋದು ಇನ್ನೊಂದು ಯಾವ್ದು ಕಂಟ್ರಿ ಕೊಡ್ತಾರೆ. ಅಂಡ್ ಡೇ ಲೆಂತ್ ಮತ್ತೆ ನೈಟ್ ಲೆಂತ್ ಹೇಳ್ತಾರೆ. ಸೊ ನಿಮಗೆ ಅಲ್ಲಿ ಡೇ ಲೆಂತ್ ನೈಟ್ ಲೆಂತ್ ಎಲ್ಲ ಗೊತ್ತಿರಲ್ಲ. ಸೊ ಎಲ್ಲಿದೆ ನೋಡಿ, ಇಫ್ ಇಟ್ ಇಸ್ ಇನ್ ಈಕ್ವೇಟರ್, day length and night length, there is no that much differences, whatever may be the season. But when you travel from equator to pole, the day length increases during summer and night length increases during winter. Okay. ಟೈಮ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡೋದು ಗೊತ್ತಿದೆಯಾ? ಹೇಗೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಆಗುತ್ತೆ? ನಮ್ಮ ಕಂಟ್ರಿಯಲ್ಲಿ ಟೈಮ್ ಹೇಗೆ, ಬೇರೆ ಕಂಟ್ರಿಯಲ್ಲಿ ಟೈಮ್ ಹೇಗೆ? ಇಂಟರ್ನ್ಯಾಷನಲ್ ಟೈಮ್ ಲೈನ್ 0 degree or 180 degree? 0 degree. Okay. Take heading as a time calculation. And Earth is circle, so 360 degree, right? Means day and night due to rotation of the earth. Yesterday we discussed about that. Day and night are due to rotation of the earth. And my question is, earth rotate from east to west or west to east? West to east. That's why eastern hemisphere experience, or eastern side of the earth experiences first sunrise. Earth rotate from east to west. That's why eastern side of the earth experiences first sunrise early in the morning. That ನಮಗೆ ಅನ್ಸುತ್ತೆ ಈಸ್ಟ್ ಇಂದ ವೆಸ್ಟ್, ನೋ ವೆಸ್ಟ್ ಟು ಈಸ್ಟ್, ದಟ್ಸ್ ವೈ ಈಸ್ಟ್ ಅಲ್ಲಿ ಸನ್ರೈಸ್ ಆಗುತ್ತೆ. ಓಕೆ, 360 ಡಿಗ್ರಿ ಬಿಕಾಸ್ ಇಟ್ ಇಸ್ ಸರ್ಕಲ್, ಎನಿ ಸರ್ಕಲ್ ಇಸ್ 360 ಡಿಗ್ರಿ, ರೈಟ್? 360 ಡಿಗ್ರಿಯನ್ನು ಕವರ್ ಮಾಡಲಿಕ್ಕೆ ಎಷ್ಟು ಹೊತ್ತು ಬೇಕು? 24 hours, right? 24 hours, right? If you calculate this, 1 hour is equal to 15 degree. 15 degree is equal to 1 hour. Then calculate ಮಾಡಿದ್ರೆ ಈಗ or 4 degree is equal to 1 minute. ಈಗ okay. This is our formula for the next time calculation. ಈ formula ನೇ ಬೇಡ. Consider this as 0 degree. 0 degree longitude means international time line. International time line 0 degree longitude. The eastern part or eastern hemisphere from 0 degree. This is western hemisphere. Western part. Here you have to add, like ನೀವು 12 o'clock ಆಗಿದ್ರೆ ನೀವು ಇಲ್ಲಿಂದ ಆಡ್ ಮಾಡ್ತಾ ಹೋಗ್ಬೇಕು. Here it is 12 o'clock means 1, 2, 3, 4, 5. The countries there in this region, that country experiences 0, I mean 12 o'clock means the country which is there in the eastern part of from this line experiences additional times like 1, 2, 3. So you have to add the time here. Here you have to subtract the time. Subtraction. Here you have to subtract the time. This is another formula. Add and subtract. In the eastern hemisphere you should add, in the western hemisphere you should subtract. This is all. ಇವಾಗ ಕ್ವೆಶ್ಚನ್ ಕೊಡ್ತೀನಿ, ಆನ್ಸರ್ ಮಾಡಿ. ಓಕೆ, ಫಾರ್ಮುಲಾ ಅದೇ, ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ ನೋಡಿ. ಈಗ ಟೇಕ್ ಎ ಕ್ವೆಶ್ಚನ್. ಈಗ at 0 degree means international time line, it is 10 p.m. It is 10 p.m. Then what is the time at, what is the time at, take A, first question, 105 degree west means here 105 degree west. And second question B, 90 degree east. 90 degree east means that side. And third question C, 120 degree east. 90 degree east, 120 degree east. Use this formula, calculate and tell me the time for A, B, C. Time is 0 degree night 10 o'clock, 10 p.m. ಹೇಗೆ ಮಾಡ್ತೀರಾ ಮಾಡಿ. ಫಸ್ಟಿಗೆ ನಾನು ಕೊಟ್ಟಿರೋ ಟೈಮ್ನ ಈ ಫಾರ್ಮುಲಾದಲ್ಲಿ ಸಬ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡಿ, ಆಮೇಲೆ ಈ ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡಿ ಒಂದು ಕನ್ಕ್ಲೂಷನ್ ಬನ್ನಿ. ಆ ಕನ್ಕ್ಲೂಷನ್ ಬಂದಿರೋ ಟೈಮ್ನ 10 p.m. ಇಂದ ಅದು ಈಸ್ಟರ್ನ್ ಪಾರ್ಟ್ ಇದ್ರೆ ಆ್ಯಡ್ ಮಾಡ್ತಾ ಹೋಗಿ, ವೆಸ್ಟರ್ನ್ ಪಾರ್ಟ್ ಇದ್ರೆ ಆ 10 p.m. ಇಂದ ಸಬ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡ್ತಾ ಹೋಗಿ. ದೆನ್ ಯು ವಿಲ್ ಗೆಟ್ ಒರಿಜಿನಲ್ ಟೈಮ್. ಫಸ್ಟ್ ಕ್ಯಾಲ್ಕುಲೇಟ್. What is the first question? Thank you. 105 degree, right? 105 west. 105 degree. So consider degree. 15 degree means 1 hour. Then 105 degree means how many hours? For 105 degree. What is the time you got? Like, what is the time? First time 7. So in the eastern part you added 11, 12. 7 ಬಂದ್ರೆ 3 ಬರುತ್ತಾ? West. Oh, ವೆಸ್ಟರ್ನ್ ಕೇಳಿದ್ದೆ ನಾನು. ಓಕೆ 7 again 3 ಬರುತ್ತೆ 3 pm ಆನ್ಸರ್ ಫೈನಲ್ ಆನ್ಸರ್ ವಾಟ್ ಇಸ್ ದ ಟೈಮ್ 3 pm right because the answer is 7 because 15 7 is the 105 right 15 7 is the 105 and here you have to subtract then 3 10 9 8 7 6 5 4 3 3 pm correct ಹೇಗೆ ಗೊತ್ತಾಯ್ತು 105 ಅದು 7 ಸಿ ಫಸ್ಟ್ ಕೊಟ್ಟಿದ್ದು ನಾನು 105 ಡಿಗ್ರಿ ವೆಸ್ಟ್ ಅಲ್ವಾ ದಿಸ್ ಇಸ್ ಡಿಗ್ರಿ 105 ಡಿಗ್ರಿ ವೆಸ್ಟ್ 15 ಡಿಗ್ರಿ ಮೀನ್ಸ್ 1 ಅವರ್ ಅಂತ ಹೇಳಿದಾಗ 105 ಡಿಗ್ರಿ ಎಷ್ಟು ಅವರ್ ನೋಡ್ಬೇಕು ನಾವು ಫಸ್ಟ್ ಆಫ್ ಆಲ್ ಸೊ 105 divided by 15 7s are 105 15 7 is the 105 ಅಲ್ವಾ 7 ಸಿಕ್ತು ನಮಗೆ ದಿಸ್ ಇಸ್ ಅ ಟೈಮ್ ಬಟ್ ಇಲ್ಲಿ 0 ಇದ್ದಿದ್ರೆ 7 ಅಂದ್ರೆ ನಾವು ಡೈರೆಕ್ಟ್ ಹೇಳ್ಬೋದಿತ್ತು ಬಟ್ ನಾವು ಇಲ್ಲಿ ಏನು ಹೇಳಿದ್ವಿ here it is 10 pm ಅಂತ ಹೇಳಿದ್ವಿ here it is 10 pm so ನಾವು ಏನು ಮಾಡಬೇಕು and this is western side means you have to subtract ಮಾಡಬೇಕು 10 ಅಲ್ಲಿ 7 ಅನ್ನು subtract ಮಾಡಬೇಕು means 9 8 7 6 5 4 means 1 2 3 4 5 6 7 means 9 8 7 6 5 4 3 7 means 3 here it is pm ಇಲ್ಲಿಂದ ಈ ಕಡೆ ಬರ್ತಾ ಹೋದಾಗ ಏನಾಗುತ್ತೆ pm ಇರುತ್ತೆ 3 pm to 10 pm ಇದನ್ನ ಹೀಗೆ ಬರಬೇಕು ನೀವು ಜಸ್ಟ್ ಏನೋ 10 minus 7 3 ಅಂತ ಮಾಡಿಬಿಡಿ ಅದು ಈ ಸೈಡ್ ಕರೆಕ್ಟ್ ಆಗುತ್ತೆ ಆ ಕಡೆ ಹೋದಾಗ ರಾಂಗ್ ಆಗುತ್ತೆ 10 minus 7 3 ಅಂತ ಮಾಡಿಬಿಡಿ ಹೀಗೆ 1 by 1 ಮಾಡಿ ಬಿಕಾಸ್ 12 ಆದ್ಮೇಲೆ ಮತ್ತೆ 1 ಇಂದ ಸ್ಟಾರ್ಟ್ ಆಗೋದಲ್ಲ ನಮ್ದು ಸೊ ಮ್ಯಾಥಮೆಟಿಕ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ವಿಲ್ ನಾಟ್ ವರ್ಕ್ ಔಟ್ ಹಿಯರ್ ಗೊತ್ತಾಯ್ತಾ ಸೊ ಡೂ ಲೈಕ್ ದಿಸ್ ಓನ್ಲಿ ವೆಸ್ಟರ್ನ್ ಪಾರ್ಟಿಗೆ ಆ ಥರ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಸರಿ ಇರುತ್ತೆ ಎಲ್ಲ ಕಡೆ ಸರಿ ಇರೋದು ಇದೇ ಥರ 3 pm ಟು ಸೆಕೆಂಡ್ ಹೇಳಿ 4 am ಹೇಗೆ 6 hours means what is the question 90 degree is 90 divided by 15 means 15 6 are right 15 6 are means 6 here it is each means you have to add 6 means 10 11 12 then 4 means 4 am 11 12 am starts so 4 am right here 10 11 12 1 2 3 4 so 6 so it is 4 am and third one 6 am what is the question 120 again 120 divided by 15 what is the answer 8 are 10 plus 8 not 18 because 11 12 then 1 2 3 4 so 6 am understood everybody ಮುಂದೋಣ gain a day lose a day ಅಂತಲ್ಲ ಇದೆ ಕಾನ್ಸೆಪ್ಟ್ ಗೊತ್ತಿದೆ ಇದು this is about international time line ಅಲ್ವಾ international date line ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ ಡೇ ಚೇಂಜಸ್ ಆಗುತ್ತೆ international time line ಅಲ್ಲಿ ಟೈಮ್ ಚೇಂಜಸ್ ಡೇ ಏನೋ ಡೇಟ್ ಲೈನ್ ಅಲ್ಲಿ ಡೇಟ್ ಚೇಂಜಸ್ ಆಗುತ್ತೆ ಅಥವಾ ಡೇ ಚೇಂಜಸ್ ಆಗುತ್ತೆ ಅದನ್ನ ನೋಡೋಣ ಇದು ಅರ್ಥ ಆಯ್ತಾ ಡೇಟ್ ಲೈನ್ ಎಲ್ಲಿರೋದು 180 degree draw that this is 180 degree. This is international date line. Normally, timeline are straight. Timeline is international timeline is very straight, and dateline is not straight. What is the reason? ಹೀಗಿಲ್ಲ dateline. Dateline ನೀವು ನೋಡಿದ್ರೆ ಹೀಗಲ್ಲ. What is the reason? What may be the reason? Timeline ಅಲ್ಲಿ straight ಇದೆ, dateline ಅಲ್ಲಿ ಹಾಗಲ್ಲ ಇದೆ. Exactly. The idea behind this cross section is single continent or single country should not experience 2 days within a single day. Like ಯಾವುದು ಇಂಡಿಯನ್ ಇದೆ ಅನ್ಕೊಳ್ಳಿ, ಇಂಡಿಯನ್ ಇದೆ, ಇಲ್ಲಿ ಮಂಡೇ ಆದಾಗ ಇಲ್ಲಿ ಟ್ಯೂಸ್ಡೇ ಇದೆ, ಸರಿ ಆಗಲ್ಲ ಫಾರ್ ಅಡ್ಮಿನಿಸ್ಟ್ರೇಟಿವ್ ಪರ್ಪಸ್. ಅದಕ್ಕೆ ಏನ್ ಮಾಡ್ತಾರೆ, ಕಾಂಟಿನೆಂಟ್ನೆಲ್ಲ ಸರಿಸಿ ಎಲ್ಲೆಲ್ಲ ಓಷನ್ ಇದೆ ನೋಡಿ, ಆ ಓಷನ್ ಮಧ್ಯೆ ತಗೊಂಡೋಗಿದೆ ಡೇಟ್ ಲೈನ್. ಓಷನ್ ಇಂದ ಆ ಕಡೆ ಬೇರೆ ದಿನ, ಡೇಟ್ ಲೈನ್ ಇಂದ ಆಚೆನೆ ಬೇರೆ ದಿನ, ಈಚೆಗೆ ಬೇರೆ ದಿನ, ಕಂಟ್ರಿ ಮಧ್ಯೆ ತಗೊಂಡೋದ್ರೆ ಏನಾಗುತ್ತೆ, ಒಂದೇ ಕಂಟ್ರಿಯಲ್ಲಿ 2 ದಿನ ಬರುತ್ತೆ, ಸಿಂಗಲ್ ಡೇ ಅಲ್ಲಿ 2 ಡೇ ಬರುತ್ತೆ. ಸೊ ಅದನ್ನ ಅವಾಯ್ಡ್ ಮಾಡಲಿಕ್ಕೆ ಇಂಟರ್ನ್ಯಾಷನಲ್ ಡೇಟ್ ಲೈನ್ ನಾವು ಸಮುದ್ರ ಮಧ್ಯೆ ತಗೊಂಡೋಗಿದೆ ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ಕಾಂಟಿನೆಂಟ್. ನಿಮ್ಗೆ ಇಂಟರ್ವ್ಯೂ ಎಲ್ಲ ಕೇಳಬಹುದಿಲ್ಲ, ಸೊ ಗೊತ್ತಿರಬೇಕು ಬೇಸಿಕ್ಸ್. So for that 180 degree, which is the eastern part or eastern hemisphere and which is the western hemisphere for this 180 degree, this is eastern side, right? And this is western side. You know Alaska? Alaska ಗೊತ್ತಿದೆಯಾ country? In which continent? Alaska in which continent? North? Exactly. And Alaska is a part of USA. Canada pakka barutte. Alaska is a part of USA. Illi barutte Alaska. It's a part of USA. Russia illi barutte. Alaska ಮತ್ತೆ Russia. And here it is. If it is Monday here, it is Tuesday here. This is standard. ಆಚೆ ಮಂಡೇ ಆದಾಗ ಮೀನ್ಸ್ 180 ಡಿಗ್ರಿಯಿಂದ ಇಂಟರ್ನ್ಯಾಷನಲ್ ಡೇಟ್ ಲೈನ್ ಈಸ್ಟ್ ಸೈಡ್ ಅಲ್ಲಿ ಮಂಡೇ ಆದ್ರೆ ವೆಸ್ಟ್ ಸೈಡ್ ಅಲ್ಲಿ ಟ್ಯೂಸ್ಡೇ. ಇವಾಗ ಕ್ವಶನ್ ಏನ್ ಬರುತ್ತೆ ಅಂದ್ರೆ ಊಹಿಸಿ, ದ ಪರ್ಸನ್ ಇಸ್ ಟ್ರಾವೆಲಿಂಗ್ ಫ್ರಮ್ Alaska to Russia. The person is traveling from Alaska to Russia. What about his day, or what happens to his day? The first option is he is going to lose a day. Second option is he is going to gain it. What is the answer? The person is traveling from Alaska to Russia. ಇದು ಏನು ಇಂಟರ್ನ್ಯಾಷನಲ್ ಡೇಟ್ ಲೈನ್, ಅದು ಇದು ಏನು ಕೊಡಲ್ಲ. ನಾವು ಅಲಾಸ್ಕಾ ಅಂಡ್ ರಷ್ಯಾ ಕ್ವಶನ್ ಬಂದಿದೆ ಅಂತ ಹೇಳಿದ್ರೆ ದಟ್ ಈಸ್ the person is traveling through international date line ಅಂತಂದ್ರೆ ನೀವು ಕಾನ್ಸೆಪ್ಟ್ ಕ್ಲಾರಿಟಿ ಬರಬೇಕು. ಓಕೆನಾ? ದಟ್ ಈಸ್ 2 countries next to the international date line, Alaska and Russia. You only should come to a conclusion like the question is on the international date line. The question is like the person is traveling from Alaska to Russia or Russia to Alaska. ಇಷ್ಟೇ ಇರುತ್ತೆ. So here if the situation is like the person is traveling from Alaska to Russia, what about his day? He will lose a day or gain a day. He is going to lose a day, right? He is going to lose a day. ಹೇಗೆ ಹೇಳಿ? ಆಲ್ರೆಡಿ ಅವನು ಮಂಡೇ ಇರ್ತಾನೆ ಇಲ್ಲಿ, ಬಟ್ 1 ಅವರಿಗೆ ಈ ಕಡೆ ರೀಚ್ ಆಗ್ತಾನೆ, ಅವನಿಗೆ ಟ್ಯೂಸ್ಡೇ ಬಂದಾಗ್ಬಿಡುತ್ತೆ. 1 ಅವರಿಗೆ ಒಂದು ಡೇನೇ ಹೋಗ್ಬಿಡುತ್ತೆ. 1 ಅವರಿಗೆ ಈ ಕಡೆ ರೀಚ್ ಆಗ್ತಾನೆ ಫ್ಲೈಟ್ ಅಲ್ಲಿ, ಬಟ್ he lost his 1 day directly for 1 hour. He receives Tuesday instead of Monday. 24 hours ಅವನು ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಮಾಡಬೇಕಿತ್ತು, ಬಟ್ 1 hour ಅಲ್ಲೇ ಅವನು ಟ್ಯೂಸ್ಡೇ ಬಂದಾಯ್ತು. So he is going to lose a day. The person is traveling from Russia to Alaska, he is going to gain a day. ಇಷ್ಟು ಸಿಂಪಲ್ ಇರುತ್ತೆ. Then also 90% of our friends going to wrong. They'll make wrong because ಈ ಇಂಟರ್ನ್ಯಾಷನಲ್ ಡೇಟ್ ಲೈನ್ ಮೂಲಕ ಹೋಗ್ತಾರೆ, ಅದರ ಕಾನ್ಸೆಪ್ಟೇ ತಲೆಗೆ ಬರಲ್ಲ. ಬಿಕಾಸ್ ದೇರ್ ಆರ್ ನೋ ಮೆನ್ಷನಿಂಗ್ ಅಬೌಟ್ ಐಡಿಯಲ್ ಇಂಟರ್ನ್ಯಾಷನಲ್ ಡೇಟ್ ಲೈನ್ ಬಗ್ಗೆ ಮೆನ್ಷನಿಂಗ್ ಇರಲ್ಲ ಕ್ವಶನ್ ಅಲ್ಲಿ. ಜಸ್ಟ್ ಎ ಕ್ವಶನ್ ಇಸ್ ಲೈಕ್ ದ ಪರ್ಸನ್ ಇಸ್ ಟ್ರಾವೆಲಿಂಗ್ ಫ್ರಮ್ ರಷ್ಯಾ ಟು ಅಲಾಸ್ಕಾ. ಅಥವಾ ಇಂಟರ್ನ್ಯಾಷನಲ್ ಡೇಟ್ ಲೈನ್ ನೀವು ನೋಡ್ಬೇಕು ಅಟ್ಲಾಸ್ ಅಲ್ಲಿ, ಅದ್ರ ಸುತ್ತ 2 ಕಾಂಟಿನೆಂಟ್ ಯಾವ್ದಾದ್ರು ಕೊಟ್ಟಿರ್ತಾರೆ. ಸೊ ಇಟ್ ಈಸ್ ಅನ್ ಈಸ್ಟರ್ನ್ ಪಾರ್ಟ್ ಆರ್ ವೆಸ್ಟರ್ನ್ ಪಾರ್ಟ್ ಅಂತ ನಾವು ನೋಡ್ಬೇಕು. ದ ಪರ್ಸನ್ ಇಸ್ ಟ್ರಾವೆಲಿಂಗ್ ಫ್ರಮ್ ವೆಸ್ಟರ್ನ್ ಟು ಈಸ್ಟರ್ನ್ ಮೀನ್ಸ್ ಯು ವಿಲ್ ಗೇನ್ ಅ ಡೇ. ದ ಪರ್ಸನ್ ಇಸ್ ಟ್ರಾವೆಲಿಂಗ್ ಫ್ರಮ್ ಈಸ್ಟರ್ನ್ ಟು ವೆಸ್ಟರ್ನ್ ಪಾರ್ಟ್ means he will lose a day. The person is traveling from eastern countries from the international date line. date line to the western countries, to the eastern date line, I mean international date line, means he will lose a day. ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಈ ಕಂಟ್ರಿಯಿಂದ ಈ ಕಂಟ್ರಿ ಬರ್ತಿದ್ದಾನೆ ಅಂತ ಹೇಳಿದ್ರೆ he going to lose a day. If the person is coming from this country to this country, ಯಾವುದಾದ್ರೂ ಕಂಟ್ರಿ ಕೊಡ್ಬೋದು, there are lot many countries, any countries ಕೊಡ್ಬೋದು. ಇಲ್ಲಿಂದ ಈ ಕಡೆ ಹೋಗ್ತಿದ್ದಾನೆ ಅಂತ ಹೇಳಿದ್ರೆ he is going to gain a day. This is all. Okay. Lose a day. Then ಇದನ್ನು ಕೇಳ್ತಾರೆ ಪ್ಲೇನ್ಸ್ ಯಾವುದು ಟೈಮ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್. ಟೈಮ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್ UPSC ಈಗ ಕೇಳ್ತಾ ಇಲ್ಲ, KPSC ಎಲ್ಲ ಕೇಳ್ತಾರೆ. UPSC ಈ ತರದ್ದು ಕೇಳ್ತಾರೆ ಡೇಟ್. ಓಕೆ, ಅಂಡರ್ಸ್ಟುಡ್? One, I'll introduce one new concept, and this concept is very very important. Take heading as a Coriolis force. Coriolis force. Everything related to atmosphere is depending on Coriolis force. It may be rocket launching, it may be flight movement. Everything is depending on the Coriolis force. Okay, what is this Coriolis force? Hello, Coriolis force ಕೇಳಿದ ಈ ನೀವು LKG UKG ಗೆಲ್ಲ ಹೋಗಿದ್ದಿದ್ರೆ ಯಾರಾದರೂ ಗ್ರೌಂಡ್ ಅಲ್ಲಿ, ಐ ಮೀನ್ LKG UKG ಚಿಕ್ಕದ ರೂಮ್ ಇರುತ್ತಲ್ವಾ, ರೂಮಿಂದ ಹೊರಗೆ ಆಟ ಆಡ್ಲಿಕ್ಕೆ ಬಿಟ್ಟಿರ್ತಾರೆ, ಒಂದಿಷ್ಟು ಪ್ಲಾಟ್ಫಾರ್ಮ್ ಮಾಡಿರ್ತಾರೆ. ಅದರಲ್ಲಿ ಒನ್ ಆಫ್ ದಿ ಪ್ಲಾಟ್ಫಾರ್ಮ್ ಇರುತ್ತೆ, ಸರ್ಕಲ್ ಇರುತ್ತೆ, ಮೆಟಲ್ ಪ್ಲೇಟ್ ಮಾಡಿರ್ತಾರೆ ಹೀಗೆ, ಅದಕ್ಕೆ ಬೇಸ್ ಇರುತ್ತೆ ಕೆಳಗೆ. ಈ ಪ್ಲೇಟ್ ಮೇಲೆ ಒಂದು 4 ಚೇರ್ ಹಾಕಿರ್ತಾರೆ ಹೀಗೆ, ಅಂಡ್ ಈ ಪ್ಲೇಟ್ ಇಟ್ಸ್ ಲೈಕ್ ರೊಟೇಟಬಲ್, ರೊಟೇಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ಬಿಡ್ತಾರೆ. ಹೀಗೆ ಯಾರು ತಗೊಂಡ್ರೆ ಹೀಗೆ ತಳ್ಳಿದ್ರೆ ಹೀಗೆ ರೊಟೇಟ್ ಆಗುತ್ತೆ. ಕನ್ಸಿಡರ್ ಹೀಗೆ ರೊಟೇಟ್ ಆಗ್ತಾ ಇದೆ, ಇಲ್ಲಿ 4 ಜನ ಕೂತಿದ್ದಾರೆ, ಇವ್ರ ಹತ್ರ ಒಂದು ಬಾಲ್ ಇದೆ, ಬಾಲ್ ಇವನಿಗೆ ಪಾಸ್ ಮಾಡಬೇಕು. ಓಕೆ, rotate ಆಗ್ತಾ ಇದೆ, and his throw ball towards him. If the ball goes like this or goes like this or this, ಆ ಕಡೆ ಹೋಗುತ್ತೆ instead of going like this. Why? It is rotating, right? Earth is also rotating, right? Earth circle ಅದು rotate ಆಗ್ತಾ ಇದೆ. So the wind, like this is Earth, and wind ಎಲ್ಲಿರುತ್ತೆ ಮೇಲೆ, ಇಲ್ಲಲ್ಲ wind. Wind ಇಲ್ಲಿಂದ ಇಲ್ಲಿ ಮೂವ್ ಆಗ್ತಿದೆ, and something which is moving on a rotating base. Atmosphere is what? Atmosphere is nothing connection ಇದೆ because of gravity. Connection ಇದೆ and base rotate ಆಗ್ತಿದೆ and wind is moving. So that ಏನಾಗುತ್ತೆ, something reflection, I mean something effect ಇದೆ ಇರುತ್ತಲ್ವಾ, same effect wind ಮೇಲೆ ಇದೆ ಇರುತ್ತಲ್ವಾ, this effect is called Coriolis force. ಹೇಗಂತ ಹೇಳಿದ್ರೆ, see, Coriolis force always acts on a right side, like something is moving from here means, like this is equator, consider wind starts from here and earth is moving, west to east rotating, not moving, rotating, and Coriolis force deflects the right side. Coriolis force deflects the winds towards right side. Coriolis effects is right side normally. ಯಾವಾಗಲೂ ಬಾಲ್ ಈಚೆಯಿಂದ ಈಚೆ ಇರ್ತದೆ, ಈಚೆ ಹೋಗಲ್ಲ, ಈಚೆ ಹೋಗಲ್ಲ, right side in a northern hemisphere. The right side in a northern hemisphere and left side ಇಲ್ಲಿಂದ ಹೊರಟಿದ್ದಾರೆ ಅಂತ ಹೇಳಿದ್ರೆ ಇದು ಲೆಫ್ಟ್ ಅಲ್ಲ, ಈಚೆ ಅಲ್ಲ ಲೆಫ್ಟ್, ಇದು ರೈಟ್ ಆಗುತ್ತೆ, ಇಲ್ಲಿಂದ ಹೊರಟಿದೆ. ಸೊ ಲೆಫ್ಟ್ ಸೈಡ್ ಇನ್ ಅ ಸದರ್ನ್ ಹೆಮಿಸ್ಫಿಯರ್. Coriolis acts, and a Coriolis force acts on an object right side in a northern hemisphere, left side in a southern hemisphere. What is Coriolis force? This is the best example. This is the best example. Something on a rotating object. The body is moving on a rotating object. That moving body experiences right side deflection in a northern hemisphere and left side deflection in a southern hemisphere. Okay, I dictate. Don't worry. Perfect. First of all, it is not a force. It is not a force. Take Coriolis force as a heading. First of all, it is not a force. It is just an effect. It is just an effect. And Coriolis force is zero at equator. Equator is zero. See, if something wind moving from here to here, like ಇಲ್ಲಿಂದ ವಿಂಡ್ ಸ್ಟಾರ್ಟ್ ಆಗಿ ಹೀಗೆ ಹೋಗ್ತಾ ಇದೆ ಅಥವಾ ಇಲ್ಲಿಂದ ವಿಂಡ್ ಸ್ಟಾರ್ಟ್ ಆಗಿ ಹೀಗೆ ಹೋಗ್ತಿದೆ ಅಂತ ಹೇಳಿದ್ರೆ ಇದ್ರ ಮೇಲೆ ಕೊರಿಯಲಿಸ್ ಫೋರ್ಸ್ ಇಲ್ಲ. ನಾರ್ತ್ ಸೈಡ್ ಅಥವಾ ಸೌತ್ ಸೈಡ್ ಹೋಗ್ತಾ ಇದೆ ಅಂದ್ರೆ ಮಾತ್ರ. ಸೊ ಕೊರಿಯಲಿಸ್ ಫೋರ್ಸ್ ಅಟ್ ಈಕ್ವೇಟರ್ ಇಸ್ zero. ಕೊರಿಯಲಿಸ್ ಫೋರ್ಸ್ ಅಟ್ ಈಕ್ವೇಟರ್ ಇಸ್ 0 and maximum at 90 degree means poles. Coriolis force is maximum at 90 degree means poles. Due to Coriolis force, any object or wind deflect right in the northern hemisphere, and left in the southern hemisphere, Right in the northern hemisphere ಅಂತ ಹೇಳೋದಕ್ಕೆ clockwise in the northern hemisphere ಅಂತ ಹೇಳ್ಬೋದಲ್ಲ. What is clockwise? Clock ಅಲ್ಲಿ ನೋಡಿದ್ರೆ ಹೀಗೆ ಅಲ್ವಾ ಅದು ರೊಟೇಟ್ ಆಗೋದು. ಗಡಿಯಾರ ನೋಡಿ ಹೀಗೆ ಅಲ್ವಾ, ಇಲ್ಲಿ 12 o'clock, 1 o'clock, 3 o'clock. So right, instead of right you can say clockwise in the northern hemisphere or anti-clockwise in the southern hemisphere. ನಾವು ಸಮೇತ ಹೇಳ್ಬೋದು anti-clockwise in the southern hemisphere. When an object is moving faster, the Coriolis force on that object would be faster. When an object is moving slower, the Coriolis force on that object would be slow, and vice versa. When an object is moving faster, the Coriolis force would be fast. When an object is moving slower, the Coriolis force on that object would be slow. That means what? ಇಲ್ಲಿಂದ ಸ್ಪೀಡ್ ಆಗಿ ಹೋಗ್ತಿದೆ ಅಂತ ಹೇಳಿದ್ರೆ Coriolis force ಹೀಗೆ, ಸ್ಲೋ ಆಗಿ ಹೋಗ್ತಿದೆ ಅಂತ ಹೇಳಿದ್ರೆ ಹೀಗೆ. See, that is the reason ನಾವು ರಾಕೆಟ್ ಲಾಂಚ್ ಮಾಡ್ತಾ ಇಲ್ಲ, ಅದು ಈ ಕಡೆ ಇದ್ರೆ ನಾವು ಸ್ವಲ್ಪ ಈಚೆ ಅಥವಾ ಅದು ಇಲ್ಲಿದ್ರೆ ನಾವು ಸ್ವಲ್ಪ ಈ ಡೈರೆಕ್ಷನ್ ಲಾಂಚ್ ಮಾಡ್ತೀವಿ. ಬಿಕಾಸ್ Coriolis force ಇಂದ ಮೇಲೆ ಹೋಗೋ ಈ ಕಡೆ ಹೋಗುತ್ತೆ ಅಂತ. ದಿಸ್ ಇಸ್ ದಿ ರೀಸನ್ ಸೈಂಟಿಸ್ಟ್ ಅಲ್ಲಿ ಇದನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ ರಾಕೆಟ್ ಲಾಂಚ್ ಮಾಡ್ತಾರೆ. ಓಕೆ, ಅಂಡ್ ಯು ನೋ ದಿಸ್ ರಾಕೆಟ್ ಲಾಂಚ್ ಅಲ್ಲ ಈಕ್ವೇಟರ್ ಮೇಲೆ ಇರುತ್ತೆ, ನಾಟ್ ಇನ್ ದ ಪೋಲ್. ವೈ? ಗ್ರಾವಿಟೇಷನ್ ಲೆಸ್ ಅಟ್ ದಿ ಈಕ್ವೇಟರ್, ಮೋರ್ ಅಟ್ ದಿ ಪೋಲ್. ವೈ? The distance from the center of the earth, core of the earth, to the pole is less, so gravity is more towards pole. The distance between center of the earth to the equator is more. That's why the earth shape is bell shape. Alva? So ಈ distance ಜಾಸ್ತಿ ಇರೋದ್ರಿಂದ gravity on equator comparatively less. Comparatively pole, gravity on equator is less because the distance is more from the earth core to the earth surface. ರಾಕೆಟ್ ಲಾಂಚ್ ಇದು ಅಷ್ಟೇ, ಫ್ಲೈಟ್ ಮೂಮೆಂಟ್ ಅಷ್ಟೇ. ಕರೆಕ್ಟ್ ಆಗಿ ಎಲ್ಲಿ ಲ್ಯಾಂಡ್ ಆಗ್ಬೇಕು ಅಲ್ಲಿಗಿಂತ ಸ್ವಲ್ಪ ಲೆಫ್ಟ್ ಸೈಡ್ ಅಲ್ಲಿ ಬರ್ತಾರೆ, ಅವಾಗ ಅದು ರೈಟಿಗೆ ಹೋಗುತ್ತೆ. ಓಕೆ, ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ Coriolis force. See, if there is no rotation, does Coriolis force was there? Consider there is no rotation. Rotation ಆಗ್ತಾ ಇಲ್ಲ ಅಂತ Coriolis force ನಮಗೆ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಆಗುತ್ತಾ? Do you experience Coriolis force? No. So rotation of the earth is the main reason for the Coriolis force of the earth. So why Coriolis force means because of rotation of earth. That's it. Because it move ಆದರೆ ಮಾತ್ರ ತಾನೇ Coriolis force ಬರೋದು. ಈ ಪ್ಲೇಟ್ ಮಕ್ಕಳು ಆಟಾಡುವಾಗ ಅದು ಮೂವ್ ಆದರೆ ಮಾತ್ರ, ನಿಂತ್ಕೊಂಡಿರುವಾಗ ಏನು Coriolis force ಇಲ್ಲ. ನಿಂತ್ಕೊಂಡಿರುವಾಗ ಇಲ್ಲಿಂದ ಬಾಲ ಇಲ್ಲಿಗೆ ಹೋಗುತ್ತೆ, ಮೂವ್ ಆಗ್ತಾ ಮಾತ್ರ. So rotating body only experiences Coriolis force. Okay. Next, the heading is a pressure gradient force. This you know, but formal definition of the this you know. What is pressure gradient force? ನಿಮ್ಗೆ ಗೊತ್ತಿದೆ ಅದು ಹೇಳಿ. Pressure gradient force. Consider here 100 pressure. 100 is 700 is pressure. Okay. Consider 900. 100 and 900. So this is the pressure. This is 100 pressure. Here it is 900 pressure. That means what? Comparatively it is high pressure. It is low pressure. And this is the region. This is one region. This is the region B. Okay. Low pressure. And wind always move from high pressure to low pressure, right? Wind always move from here to here. Okay. Consider here it is 1200 pressure. Here it is 700 pressure. What happened? The pressure differences got increases, right? Or pressure difference got increased. Means here it is very high pressure and here it is very low pressure. So the speed of the wind would be slower or faster? Faster. This is called pressure gradient force. The pressure is depending on the difference of the pressure. I mean the force, the wind force is depending on the difference in the pressure. Wind always blow from high pressure to low pressure and the speed of the wind is depending on the pressure difference. Next, frictional force. What is friction? Friction means what? Friction ಅಂದ್ರೆ ಏನು? Friction. Tikata. Alva? My question is, friction is on a moving body or on a settled or stable body? We experience friction on a moving body or a settled body. Moving body ಅಲ್ಲಿ ಮಾತ್ರ friction ಬರುತ್ತೆ. Settled body ಅಲ್ಲಿ friction ಇರೋದಿಲ್ಲ. Okay. So this frictional force is on a moving body, first one. And this always acts on a direction which is opposite to the body moving. Frictional force acts on a direction which is opposite to the body is moving. Wheel ಇದೆ ಅನ್ಕೊಳ್ಳಿ. Consider a wheel. ಒಂದು ಯಾವ್ದು wheel ಇದೆ. ನಾರ್ಮಲ್ ಆಗಿ ಈ ಗ್ರೀಸಸ್ ಆಯಿಲ್ಸ್ ಅನ್ನೆಲ್ಲ ಫ್ರಿಕ್ಷನ್ ಕಮ್ಮಿ ಆಗಲಿ ಅಂತ ಯೂಸ್ ಮಾಡ್ತೀವಿ ಅಲ್ವಾ? ಇವಾಗ ಫ್ರಿಕ್ಷನ್ ಇದ್ರೆ ಅದು ಕ್ಲೀನ್ ಆಗಿ ತಿರುಗಲ್ಲ, ರನ್ ಆಗಲ್ಲ. ಅದಕ್ಕೆ ಆಯಿಲ್ ಅಥವಾ ಗ್ರೀಸ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ? ಫ್ರಿಕ್ಷನ್ ಕಮ್ಮಿ ಆಗುತ್ತೆ, ಸೊ ಕ್ಲೀನ್ ಆಗಿ ರನ್ ಆಗುತ್ತೆ. ಚೆನ್ನಾಗಿ ರನ್ ಆಗುತ್ತೆ ಮೀನ್ಸ್ ವಾಟ್? ಆ ರನ್ ಆಗೋದ್ರದ್ದು ಆಪೋಸಿಟ್ ಯಾವುದು ಫೋರ್ಸ್ ಇಲ್ಲ ಅಂತ. So it is opposite on a moving body. Like if there is a frictional force means what? ಅದಕ್ಕೆ movement slow ಆಗುತ್ತೆ. Movement slow ಆಗುತ್ತೆ means what? That is opposite to the direction of the wheel running alva. That's what I am trying to tell you. Frictional force is the force is on a opposite direction of the moving body. ಇವಾಗ ರೈಲ್ವೆ ಟ್ರ್ಯಾಕ್ ಮೇಲೆ ಇದು ವೀಲ್ ಹೋಗ್ತಾ ಇರುತ್ತೆ ಟ್ರೈನ್. ಫ್ರಿಕ್ಷನ್ ಇದ್ರೆ ಸ್ಪೀಡ್ ಹೋಗುತ್ತೆ, ಫ್ರಿಕ್ಷನ್ ಇಲ್ಲ ಅಂದ್ರೆ ಸ್ಪೀಡ್ ಹೋಗುತ್ತೆ. ಫ್ರಿಕ್ಷನ್ ಇಲ್ಲ ಅಂತ ಹೇಳಿ, ಫ್ರಿಕ್ಷನ್ ಇಲ್ಲ ಮೀನ್ಸ್ ವಾಟ್? ಅದು ಸ್ಪೀಡ್ ಹೋಗುತ್ತೆ. ಫ್ರಿಕ್ಷನ್ ಇಲ್ಲದಿದ್ರೆ ಸ್ಪೀಡ್ ಹೋಗುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ, ಫ್ರಿಕ್ಷನ್ ಇದ್ರೆ ಸ್ಪೀಡ್ ಕಮ್ಮಿ ಆಗುತ್ತೆ ಮೀನ್ಸ್ ಇಟ್ ಈಸ್ ಆಪೋಸಿಟ್ ದಿ ಮೂವ್ಮೆಂಟ್ ಆಫ್ ದಿ ವೀಲ್. ಓಕೆ, ಆ ಕಾನ್ಸೆಪ್ಟ್ ಅದು ಕೇಳ್ತಾರೆ. ಫ್ರಿಕ್ಷನ್ ಫೋರ್ಸ್ ಇಸ್ ಆಲ್ವೇಸ್ ಆನ್ ಆಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ ಆಫ್ ದಿ ಬಾಡಿ ವಿಚ್ ಇಸ್ ಮೂವಿಂಗ್, ರೈಟ್? ಫ್ರಿಕ್ಷನ್ ಇದ್ರೆ because of friction the speed of that body going to decreases. That's why it is opposite direction of the movement of the moving object. It is on opposite direction of the where it is moving. So when there is a friction means the speed going to decrease. This is and friction by moving, I mean wheels ಅಲ್ಲಿ ಎಲ್ಲ ಮಾತ್ರ ಇರೋದಾ? ಹಾಗಲ್ಲ ಏನಿಲ್ಲ. ನಾವು ಡ್ರೆಸ್ ಹಾಕಿದ್ವಿ, ನಮ್ಮ ಬಾಡಿ ಮೇಲೆ ಡ್ರೆಸ್ ನಿಂತಿದೆ ಅಂದ್ರೆ ದಟ್ ಇಸ್ ಆಲ್ಸೋ ಬಿಕಾಸ್ ಆಫ್ ಫ್ರಿಕ್ಷನ್. ದೇರ್ ಇಸ್ ನೋ ಫ್ರಿಕ್ಷನ್ ಯಾವುದಿಲ್ಲ. ಮನೆ ನಿಂತಿದೆ, ಬಿಲ್ಡಿಂಗ್ ನಿಂತಿದೆ, ಎವ್ರಿಥಿಂಗ್ ಇಸ್ ಬಿಕಾಸ್ ಆಫ್ ಫ್ರಿಕ್ಷನ್ ಅಲ್ವಾ? ಫ್ರಿಕ್ಷನ್ ಇಸ್ ಲಿವಿಂಗ್. ಎಸ್ ಎಸ್ ಫ್ರಿಕ್ಷನ್. ನಾವು ನಡ್ಕೊಂಡು ಹೋಗೋ ಕರೆಕ್ಟಾಗಿ ಶೂಸ್ ಎಲ್ಲ ನಿಂತಿದೆ, ಅದೆಲ್ಲ ಬೆಲ್ಟ್ ನಿಂತಿದೆ, ಎವ್ರಿಥಿಂಗ್ ಇಸ್ ಬಿಕಾಸ್ ಆಫ್ ಫ್ರಿಕ್ಷನ್ ಅಲ್ಲಿ. ಫ್ರಿಕ್ಷನ್ is not a bad concept. Friction should be there, but ಎಲ್ಲಿರ್ಬೇಕು ಅಲ್ಲೇ ಇರಬೇಕು. It is on a wheel means that is difficult, that is bad. But friction should be there in a universe. Otherwise, there is no universe. Alva, building infrastructure, everything stood because of friction. This is friction force. And we discuss pressure gradient force, and we discuss Coriolis force. Let's club all the forces. Merge one. Consider, here it is 1000 pressure, here it is 500 pressure, two places, and wind is started from here, moving towards like this north side. If there is no friction, there is no Coriolis force means wind which started from here ends here, right? Wind which started from here, Coriolis starts from here and ends up with here. If there is no Coriolis force, no friction force. Because of Coriolis force, winds in the northern hemisphere experiences are shift towards right side, right? Coriolis force illa anta helidre illi reach agtittu. Adre Coriolis force irodrinda instead of reaching here, it would reach here, right? And in between we have another force called frictional force. Frictional force is also there for the wind, right? Flight move ಆಗ್ತಿದೆ ಅಂತ ಹೇಳಿದ್ರೆ ವಿಂಡ್ ಇಂದ ಫ್ರಿಕ್ಷನ್ ಕ್ರಿಯೇಟ್ ಆಗುತ್ತೆ. ಫ್ರೀಲಿ ಮೂವಿಂಗ್ ಬಾಡಿ ಗೋಸ್ ಮೇಲೆ ಬಿಕಾಸ್ ಆಫ್ ವಿಂಡ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸಸ್ ಫ್ರಿಕ್ಷನ್. ಸೊ ಈ ಬಾಡಿ ಮೂವ್ ಆಗ್ತಿದೆ ಅಂತ ಹೇಳಿದ್ರೆ ಬಿಕಾಸ್ ಆಫ್ Coriolis, this is because of Coriolis force. ಇಷ್ಟು ಈ ಕಡೆ ಹೋಗಿದೆ. If there is no Coriolis force means it will be like this. Because of frictional force, it will not go this much right side because frictional force always acts against the moving body. ಇದು ಈಚೆ ಹೋಗ್ಲಿಕ್ಕೆ ಟ್ರೈ ಮಾಡ್ತಿದೆ ಅಂತ ಹೇಳಿದ್ರೆ again means it is opposite direction. ಇದು opposite ಈ ಕಡೆ ಇರ್ತದೆ, ಈ ಕಡೆ ಇರ್ತದೆ. This is the resultant force. This resultant force is because of the frictional force. Because of pressure gradient force, the wind blowing from here to here, because here 1000 pressure, here 500 pressure, and if there is no other forces, it ends up here. Because of the Coriolis force, it diverted towards right side, and because of frictional force, again it came back here in the middle. So this is the resultant force. Normally, an equator, high temperature, right? High temperature always associated with high temperature associated with low pressure. When there is a low pressure, winds ascends or descends first class. When there is a low pressure, winds ascends or descends. Now first class only here there is earth, and because of high temperature, low pressure creates. Because of low pressure, winds going to ascend, and again low pressure creates the wind from the surrounding region move towards here, again it breaks. So high temperature, normally relates with low pressure. ಇದೆಲ್ಲ ಹೇಳಿದ್ದೆ ಫಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ನೆನಪಲ್ವಾ? That means what? On equator normally high temperature. High temperature means because sun rays directly falls on the equator. High temperature means what about pressure? Low pressure. Low pressure means wind always descend ಅಲ್ಲ ಮೇಲ್ ಹೋಗುತ್ತೆ. ಅಸೆಂಡಿಂಗ್ ಆರ್ಡರ್ ಮೀನ್ಸ್ ಮೇಲ್ ಹೋಗುತ್ತಲ್ವಾ? ಅರ್ಥ ಆಗ್ತಾ ಇಲ್ವಾ? ಸಿ ಯಾವುದಾದ್ರೂ ಏರಿಯಾದಲ್ಲಿ ಟೆಂಪರೇಚರ್ ಜಾಸ್ತಿ ಆಗಿದೆ ಅಂತ ಹೇಳಿದ್ರೆ ಹೈ ಟೆಂಪರೇಚರ್ ಆಲ್ವೇಸ್ ಅಸೋಸಿಯೇಟೆಡ್ ವಿತ್ ಲೋ ಪ್ರೆಷರ್. ವೆನ್ ಲೋ ಪ್ರೆಷರ್ ಮೀನ್ಸ್ ಟೆಂಪರೇಚರ್ ಜಾಸ್ತಿ ಆಗಿದೆ ಲೋ ಪ್ರೆಷರ್ ಇದೆ ಅಂತ ಹೇಳಿದ್ರೆ ಅಲ್ಲಿರೋ ವಿಂಡ್ ಮೇಲೆ ಹೋಗುತ್ತೆ. ಅಲ್ಲಿ ಎಂಟಿ ಸ್ಪೇಸ್ ಕ್ರಿಯೇಟ್ ಆಗುತ್ತಲ್ವಾ? ದಿಸ್ ಸ್ಪೇಸ್ ವಾಸ್ ಫಿಲ್ಡ್ ಅಪ್ ಬೈ ದ ಸರೌಂಡಿಂಗ್ ಏರ್. That's why the air comes and clump and again rise. Comes and rise means converge and ascend. Converge and ascend. First class discuss ಮಾಡಿದ್ವಿ. That means on equator normally it experiences this kind of situation. ಇದನ್ನ ಸರ್ಫೇಸ್ ಆಫ್ ದ ಅರ್ಥ ಅಂತ ತಗೊಂಡ್ಬೇಕು. ಎಲ್ಲಿ ತನಕ ಮೇಲೆ ಹೋಗುತ್ತೆ? Converge and rise ಅಂತ ಹೇಳಿದೆ. Rise up to in troposphere, stratosphere, mesosphere, thermosphere ಹೋಗುತ್ತೆ. Then up to tropopause, right? Tropopause ಇಂದ ಮೇಲೆ ಹೋಗಲ್ಲ because conduction starts. Only in the troposphere there is a convection. After tropopause there is a conduction. What is convection? With increasing age, temperature decreases. That is called convection. With increasing age, temperature increases. That is conduction. And only in the troposphere and mesosphere we experiences convection. Discuss. So till tropopause, the wind going to rise. After that, it will not. So consider this as a tropopause. Then what happens? Then it diverges, right? Again diversion. It shifts its direction. Consider ಇಲ್ಲಿ ಯಾವುದು ಬೇರೆ ಇಲ್ಲ. ಇಲ್ಲಿ ನಾರ್ಮಲ್ ಆಗಿ ಪೋಲರ್ ವಾಟ್ ಇಸ್ ದ ಟೆಂಪರೇಚರ್? Low temperature means high pressure. High pressure I told you. When there is a high pressure, wind ascends or descends? High pressure means wind going to descend. Means ಕೆಳಗೆ ಬರುತ್ತೆ ಅಲ್ವಾ? ಸೊ ಇಲ್ಲಿಂದ ಬಂದಿರೋ wind right? The length between this and this, I made a difference. The reason here I made a difference. ಇಲ್ಲಿ ಇಷ್ಟು wide ಕೊಟ್ಟೆ, ಇಲ್ಲಿ ಕಮ್ಮಿ ಕೊಟ್ಟೆ space. What is the reason? In the first class we discussed the troposphere length or the width of the troposphere is 18 kilometers at the equator and 88 kilometers at the pole. We discussed this because at the pole gravity is more. Because of gravity it attracts the air particles. Because of gravity, because of high intensive gravity at the pole, the troposphere at the pole is less. The width of the troposphere at the pole is less because of high gravity. And because of less gravity at the equator we experiences lengthier or wider troposphere. ಇದನ್ನ ನಾನು ಅದಕ್ಕೆ ಇಲ್ಲಿ ವೈಡ್ ಜಾಸ್ತಿ ಇಲ್ಲಿ ವೈಡ್ ಕಮ್ಮಿ. ವಿಡ್ತ್ ಜಾಸ್ತಿ ಇಲ್ಲಿ ವಿಡ್ತ್ ಕಮ್ಮಿ. So what is this? This is tropopause. Tropopause. Right. This is called unicellular model. ಒಂದೇ ಸೆಲ್ ಅಲ್ಲ. ಇಲ್ಲಿಂದ ಇಲ್ಲಿವರೆಗೆ consider this as one room. Unicellular model. But this is not practically correct. This is theoretical. Practically, might want to bear a name. Let's discuss about it. See, or this is unicellular model and this is theoretical. Practically, the matter is different because this Earth is not a standing object. It is a rotating object. When there is a rotating object means it is a Coriolis force. ಇಲ್ಲಿಂದ ಹೊರಟಿರೋದು wind. Coriolis force ಇಲ್ಲ ಅಂತ ಹೇಳಿದ್ರೆ ಇಲ್ಲಿ ತನಕ ರೀಚ್ ಆಗ್ತಿತ್ತು. Because of Coriolis force, ಇದು it shifts its direction. It shifts or changes its direction. Okay, and it changes its direction towards two sides. One in between the 0 degree to 90 degree. 45 and 30 and 60 ಡಿಗ್ರಿ ಎರಡು ಹೈ ಪ್ರೆಷರ್ ಅಂಡ್ ಲೋ ಪ್ರೆಷರ್ ಏರಿಯಾ ಬರುತ್ತೆ. ಅಲ್ಲಿ ಶಿಫ್ಟ್ ಆಗಿ ಮತ್ತೆ ಕೆಳಗೆ ಮತ್ತೆ ಮೇಲೆ ಹೋಗುತ್ತೆ. ಅಂಡ್ ದಟ್ ಇಸ್ ದ ಡಿಫರೆನ್ಸ್. ಅದು ನಾವು ಒಂದೇ ನೋಡ್ತಾ. ಅಂಡ್ ದಿಸ್ ಯುನಿಸೆಲ್ಯುಲರ್ ಮಾಡೆಲ್ ಇಸ್ ಓನ್ಲಿ ಅ theoretical model. This is not practically correct because Earth is a rotating object. In the rotating object, the moving body means the wind which moving experiences Coriolis force. Because of Coriolis force, there will be no unicellular model. There is three cellular model. Means ಇದು ಇಲ್ಲೊಂದ್ಸತಿ ಡಿವೈಡ್ ಆಗುತ್ತೆ, ಇಲ್ಲೊಂದ್ಸತಿ ಡಿವೈಡ್ ಆಗುತ್ತೆ, ಮೂರು ಸೆಲ್ ಆಗುತ್ತೆ. ಇಲ್ಲಿಂದ ಹೊರಟಿರೋ ವಿಂಡ್ ಇಲ್ಲಿ ತನಕ ಹೋಗಲ್ಲ ಬಿಕಾಸ್ Coriolis force ಇಂದ ಚೇಂಜ್ ಆಗುತ್ತೆ. ಓಕೆ, ದಿಸ್ ಇಸ್ ಓಕೆ. ನೋಡ್ತಾ ಒಂದೊಂದೇ ವಾಟ್ ಇಸ್ ರೈಟ್. If the question is like the wind experiences tricellular model, not a unicellular model, what is the reason? What is the main reason? Coriolis force. Okay. The heading is a tricellular circulation. Tricellular circulation. Consider this as a 0 degree. And this is a 90 degree. This is a 30 degree. This is a 60 degree. 0 degree means high temperature, right? Means low pressure. Pole, low temperature means high pressure. The wind which started from here, ಈಚೆನೂ ಇದೆ ವಿಂಡ್. ದಿಸ್ ಇಸ್ ಫಾರ್ ದಿಸ್ ಸೈಡ್. ಇದು ಯಾವುದೋ ಒಂದು ಹೆಮಿಸ್ಫಿಯರ್ ಅಂತ ಅಂದ್ಬಿಡು. ಇದು ನಾರ್ದರ್ನ್ ಹೆಮಿಸ್ಫಿಯರ್ ಅಂದ್ಬಿಡು ಅಥವಾ ಸದರ್ನ್ ಹೆಮಿಸ್ಫಿಯರ್. ನಾವು ಇದನ್ನ ಸಿ ಈ ಅರ್ಥ ಇದೆ ಅಲ್ವಾ, ಇಲ್ಲಿಂದ ಇಲ್ಲಿ ತನಕ ಪಾರ್ಟ್ ನಾವು ನೋಡಿದ್ವಿ. ದಿಸ್ ಪಾರ್ಟ್ ಇದನ್ನೇ ನಾವು ಹೀಗೆ ಬರ್ದಿಲ್ಲ ಅರ್ಥ ಆಯ್ತಲ್ವಾ, ಇಲ್ಲಿದೆ ಅಲ್ವಾ ಈ ಅರ್ಥ, ಇಲ್ಲಿಂದ ಇಲ್ಲಿಂದ ಹೀಗೆ ಬರ್ದಿದ್ವಿ ನಾವು. ಓಕೆ, ದಿಸ್ ಇಸ್ ಎಲ್ಲಿ ತನಕ ರೀಚ್ ಆಗುತ್ತೆ ಇದು ಇಲ್ಲಿವರೆಗೆ ಅಂತ ಹೇಳಿದೆ. ಇಲ್ಲಿಂದ ಇಲ್ಲಿವರೆಗೆ ವಾಟ್ ಇಸ್ ದಿಸ್, ಇಲ್ಲಿಂದ ಇಲ್ಲಿವರೆಗೆ ಇಲ್ಲಿ ತನಕ ರೀಚ್ ಆಗುತ್ತೆ ಅಂತ ಹೇಳಿದ್ವಲ್ವಾ. ವಾಟ್ ಇಸ್ ದಿಸ್ ದೇರ್, tropopause. So this is the tropopause. Tropopause in picture. After reaching tropopause, it starts to diverge. One of the wind moves like this, and some of the wind moves like this, and here it descends alva. ಈ ಕಡೆ ಹೋಗ್ತಾ ಮೇಲೆ ಹೋಗಲ್ಲ, ಅಸೆಂಡಿಂಗ್ ಆರ್ಡರ್ ಹೋಗಲ್ಲ, ಡಿಸೆಂಡಿಂಗ್ ಅಲ್ಲಿ ಬರುತ್ತೆ ಅಲ್ವಾ. ಯಾಕೆ? ಬಿಕಾಸ್ ಇಟ್ ಮೂವಿಂಗ್ ಟುವರ್ಡ್ಸ್ ಪೋಲ್. ಪೋಲ್ ಕಡೆ ಹೋಗ್ತಿರೋದ್ರಿಂದ ಕೆಳಗೆ ಬರ್ತಾ ಹೋಗುತ್ತೆ, ಇಲ್ಲಿಗೆ ಬರ್ಬೋದು. ಇನ್ 30 ಡಿಗ್ರಿ ಕಂಪೇರಿಟಿವ್ಲಿ ಲೋ ಟೆಂಪರೇಚರ್, ಕಂಪೇರಿಟಿವ್ಲಿ ಈಕ್ವೇಟರ್ ಇಟ್ ಇಸ್ ಲೋ ಟೆಂಪರೇಚರ್ 30 ಡಿಗ್ರಿ ಅಲ್ವಾ. ಕಂಪೇರಿಟಿವ್ ಈಕ್ವೇಟರ್ 30 ಡಿಗ್ರಿ ನಾರ್ತ್ or 30 degree south is a low temperature compared to equator. So low temperature associated with high pressure comparatively. When it is high pressure means what happens to the wind? Is it descends or ascends? That is the reason wind going to descend here. That is the reason wind going to descend here. Okay? Descending wind. After descending, what happens? The wind is descending in 30 degree. It will descend up there. Then one of the branch moves like this and one of the branch moves like this. Normal line. Alva? ಇಲ್ಲಿ reach ಆದ್ಮೇಲೆ one branch ಈ ಕಡೆ one branch ಈ ಕಡೆ ಹೋಗುತ್ತೆ. Then one branch ಈ ಕಡೆ ಇಲ್ಲಿ ಕೆಳಗೆ ಬಂದಾಗ one branch moves like this towards equator, another branch moves like this towards polarization. Right? So descending and diverging winds. So, there was a cube created here, like one cell created. This cell is called Hadley cell. Hadley cell. Hadley cell ಅಂತ ಕರೀತಾರೆ. Here it is low temperature. Here it is very low temperature. Compared to pole, 60 degrees high temperature, right? Compared to pole, compared to 90 degrees, 60 degrees somewhat high temperature. So it is high temperature. And it is high temperature, low pressure. See, the wind is moving like this. Wind is moving like this. And in lower temperature, in lower pressure region, wind ascends, not descends. So it ascends till tropopause, and tropopause here is like only like this because it is near to pole. Tropopause. So after reaching tropopause, one of the branch moves like this, and another branch moves like this, right? Like this. And after reaching 30 degrees, again it descends. Again it descends because here it is high pressure area. High pressure area descending here. Low pressure area ascending here. After reaching 30 degrees, again descends. Right? This is called, what is the name for this? Ferrule cell. Ferrule cell. Hadley cell, ferrule cell. See, this is one branch. And another branch, after reaching here, is more like this. And in the high pressure area, high pressure means always air descends. So comes like this. And after reaching the ground, it moves like this. This is called polar cell. These are the three different cells in the atmosphere. This is the polar cell. Polar cell, ferrule cell, Hadley cell. Okay. Why the width gap, or the width distance is different here and here? The reason is here it is pole, here it is equator. And why here it descends? Because it is a high pressure area. High pressure means wind descend and diverge. And why here it is ascending? Because comparatively it is high temperature, means low pressure. When there is a low pressure area, means like equator. Here ascends and reaches tropopause and it diverges, right? And one of the branch moves towards the pole, and pole normally low, very low temperature means comparatively high pressure. High pressure means descends. This is all. Okay. Diagram over and dictate something. Unicellular circulation. Unicellular circulation did not consider the impact of Coriolis force. The impact of Coriolis force. If we include Coriolis force, then we observe tricellular circulation. If we include Coriolis force, then we observe tricellular circulation. Do you know solar radiation near equator? You know solar radiation near equator. We observe high temperature and low pressure. We observe high temperature and low pressure. Because of this converging and rising of air. Because of this converging and rising of air. Near poles, near poles we observe low temperature and high pressure. That is descending and diverging air. Descending and diverging air. From poles, wind blow towards equator. From poles, wind blow towards equator. Full stop. Next paragraph. Near equator, the upper air diverges towards pole. Diverges towards pole. In a non-frictional layer. In a non-frictional layer. Due to this, see, I told you in a non-frictional layer. Why? Here friction more or here friction more? Near to the ground, friction more because density of the air is more towards the earth. When you move higher altitude, density going to decreases. Because why higher density near the ground? Because of the gravitational force of the earth. When you move above, the density of air going to decrease. When there is no density, means friction is less. Okay, this is all. In a non-frictional layer, due to Coriolis force, in a non-frictional layer, due to Coriolis force, they descends at 30 degree. They descend at 30 degree. The descending air diverges. The descending air diverges near ground. Diverges. The descending air diverges near ground surface. One branch more towards equator. One branch more towards equator, connected right, don't write blindly. Another branch going towards pole. The first branch which is moving towards equator, the branch which moves towards equator, again rise near equator. The branch which moves towards equator, again rise at equator, and this form a cell, and this form a one complete cell or cell. This is called Hadley cell. This form a cell, and this is called Hadley cell. Another branch which is moving towards poles. Another branch which is moving towards poles converges with winds. Which is moving from the poles. Converges with winds which is moving from the poles at 60 degree. Converges with the winds which is moving from the poles at 60 degree, and they rise. And the rising air diverges near tropopause, and rising air diverges near tropopause. One branch moving towards equator, and converge with Hadley cell. And descends to form ferrule cell. Another branch which move towards pole, another branch which move towards pole, descends at 90 degree or descends at the pole to form polar cell. To form polar cell. To form polar cell. Full stop. Due to this, we observe 3 cells in the northern hemisphere and 3 cells in the southern hemisphere. Three cells in the northern hemisphere, 3 cells in the southern. Total how many cells on Earth? 6 cells. In between 7 pressure beds. See, 6 cells in between 7 pressure beds. This is called pressure beds. These are the pressure beds, okay? See, 7 pressure beds. Why? Here 1, 2, 3. And in the southern side 1, 2, 3. And this one, equator. 3 plus 3 plus 1. 7 pressure beds. Okay. In the 7 pressure beds, this one, 1, 2, and another side 3. 3 are low pressure beds. In the 7 pressure beds, 3 are low pressure beds. One is at equator, another is at 6 degree north, and another one is at 6 degree south. These are the 3 low pressure beds and 4 high pressure beds. 90, 30, 90, 30. 4 high pressure beds. These are the important things. 3 low pressure beds and 4 high pressure beds. This is all. And the 3 high pressure beds are called thermally induced. Why it is called thermally induced low pressure beds? Because where there is a low pressure, there is a high temperature. Thermally means temperature related. So that is called thermally induced. And 4 high pressure beds are called dynamically induced. Dynamically induced. Thermally induced are 3. Dynamically induced are 4. Total 7 pressure beds and 6 cells. Okay? This is what very, very important. Directions ಎಲ್ಲ ಗೊತ್ತಿದೆಯಲ್ಲ ನಿಮಗೆ. ನಾನು ನಾರ್ತ್ ಸೌತ್ ಈಸ್ಟ್ ವೆಸ್ಟ್ ಅಂತ ಹೇಳ್ತಾ ಇದ್ದೀನಿ. See, this is north, okay? That is north. This is south. This is east and this is west. Northeast, southeast, southwest, northwest. The entire like earth ಮೇಲೆ ನೋಡೋಣ ಇದು. This is one side ಅಲ್ವಾ? ಇದು ಯಾವುದು? ಇಲ್ಲಿಂದ ಇಲ್ಲಿವರೆಗೆ ನಮ್ದು. Entire earth ಮೇಲೆ ನೋಡೋಣ. What is like trade winds ಗೊತ್ತಿದೆ ನಿಮಗೆ? South western trade winds, south eastern trade winds, westerlies. These are the different winds. ಗೊತ್ತಿಲ್ವಾ? What is south eastern trade wind? Trade winds means what? Trade winds related to trader. Trade winds are westerly. What is the differences? See, normally the winds gets its name because of where it arises, the place where it arises. ಎಲ್ಲಿಂದ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ ಅಲ್ಲಿಂದ ನೇಮ್ ಸಿಗುತ್ತೆ ವಿಂಡ್ಗಳಿಗೆ. ವೆಸ್ಟರ್ಲೀಸ್ ಮೀನ್ಸ್ ಮೇ ಬಿ ಇಟ್ ಸ್ಟಾರ್ಟ್ಸ್ ಫ್ರಮ್ ದಿ ವೆಸ್ಟ್ ಸೈಡ್. ಈಸ್ಟರ್ಲಿ ಮೀನ್ಸ್ ಮೇ ಬಿ ಇಟ್ ಸ್ಟಾರ್ಟ್ಸ್ ಫ್ರಮ್ ಈಸ್ಟ್. ಯಾವ ಕಡೆ ಹೋಗ್ತಿದೆ ಅದಲ್ಲ, ಎಲ್ಲಿಂದ ಬರ್ತಾ ಇದೆ. ವೆಸ್ಟರ್ಲಿ ಮೀನ್ಸ್ ಇಟ್ ಮೂವಿಂಗ್ ಟುವರ್ಡ್ಸ್ ಈಸ್ಟ್ ಸೈಡ್. ಇಟ್ ಅರೈಸ್ಡ್ ಇನ್ ವೆಸ್ಟ್ ಸೈಡ್. Easterly means it going towards west side actually. It arrives from east side. That's why the name Easter. Hi. Okay. ಒಂದು ದೊಡ್ಡ ಸರ್ಕಲ್ ಹಾಕಿ ಹಾಫ್ ಪೇಜ್ ಆಫರ್ 3/4 of the page. Consider this as the earth. Degree north, 5 degree south. This is northern pole and this is southern pole. Southern pole. And this is equator. Equator means 0 degree. 0 degree. Okay. ITCZ Intratropical Convergence Zone ಅಂತ ಕರೀತೀವಿ. ಜಸ್ಟ್ ಬರ್ಬೇಡಿ ನಾನು ಹೇಳ್ತೀನಿ. This is the equator. Normally, in the equator, winds blow like this. Blow like this means what? Here it is west, right? Here it is east. Means this is westerly or easterly. Normally winds. So that's why the name equatorial westerlies. The winds blowing here are called equatorial westerlies. Equatorial westerlies. ಇವಾಗ ಕೊರಿಯಲಿಸ್ ಫೋರ್ಸ್ ಅನ್ನು ಅಪ್ಲೈ ಮಾಡೋಣ. ಓಕೆ, ಸಿ ಅದಕ್ಕಿಂತ this is trade winds. The wind which start from here are called trade winds. ಅಥವಾ ಇಲ್ಲಿಂದ ಇದು trade latitude ಅಂತ ಕರೀತೀವಿ. And normally 25 to 35 means in between 30 is there. And 30 is a high pressure belt or low pressure belt. High pressure belt, right? 30 is a high pressure belt. Equator, high temperature, low pressure. And 30 degree comparatively low temperature means high pressure. So subtropical high pressure. Subtropical high pressure belt ಅಂತ ಕರೀತೀವಿ. Subtropical high pressure. So trade latitude ಅಥವಾ horse latitude ಅಂತ ಎರಡು ಹೆಸರಿದೆ. Trade latitude, horse latitude between 25 to 35 we call it as a subtropical high pressure area or trade latitude or horse latitude. Because ancient Indian time horse import and export through this latitude ಆಗ್ತಿತ್ತು. Horse ಅನ್ನು ಒಂದು ಕಡೆಯಿಂದ ಇನ್ನೊಂದು ಕಡೆ ಹಡಗುವಲ್ಲಿ ತಗೊಂಡು ಹೋಗ್ತಾ ಈ latitude ತಗೊಂಡು. That's why the name horse latitude. That's why. Okay. Then what is the 60-degree area? Low pressure area, right? Low pressure area, comparatively higher temperature than poles. That's why high temperature means low pressure, means subpolar low pressure. Subpolar low pressure region. Subpolar low pressure region. 30 degree, 25 to 30 degree, 35 degree called as subtropical high pressure area, and 55 to 65 degree subpolar low pressure area. Here also subtropical high pressure area and subpolar low pressure area. Okay, and this is the poles. This is the 90 degree pole, and this is a 90 degree pole. Okay. Now, westerlies. See, normally the the winds which blow here are called trade winds. Illi ಬೀಸೋ ಗಾಳಿಗೆ trade winds ಅಂತ ಕರೀತೀವಿ. Because it's a subtropical high pressure area. ಈ wind means trade latitude, horse latitude ಅಂತ ಹೇಳಿದಾಗ, so ಈ ಏರಿಯಾದಲ್ಲಿ ಬೀಸೋ ಗಾಳಿಗಳಿಗೆ trade winds ಅಂತ ಕರೀತೀವಿ. Trade winds. Okay, and the wind which blow here are called westerlies. Westerlies. Okay. Westerlies andele west in the east kade ಬೀಸ್ತಾ ಇರುತ್ತೆ. And I told you here it is westerly means west in the east kade. Here it is easterlies ಅಂತ ಕರೀತೀವಿ. polar. Easterlies means here also easterlies means what? East to west ಬೀಸ್ತಾ ಇರುತ್ತೆ. polar easterlies ಅಂತ ಕರೀತಾರೆ ಅಥವಾ easterlies ಅಂತ ಹೇಳ್ಬೋದು. Okay, this is all. Okay, ಇವಾಗ let's apply our Coriolis force knowledge to this atmosphere. The wind started from here, like ಇದು ಮೂವ್ ಆಗ್ತಾ ಇದೆ, ನಾರ್ತ್ ಸೈಡ್ ಮೂವ್ ಆಗಕ್ಕೆ ಟ್ರೈ ಮಾಡ್ತಾ ಇದೆ, ಇಲ್ಲಿಂದ ಅರೈಸ್ ಆಗಿದೆ. Then it shifts towards which direction? It is on a northern hemisphere. So in the northern hemisphere, Coriolis force towards the right direction. So shifts towards like this wind which blow from here move towards like this. The winds which started here and it wants to move here, southern side ಬರ್ಲಿಕ್ಕೆ ಟ್ರೈ ಮಾಡ್ತಾ ಇದೆ. ಅವಾಗ ಇದು this is A, this is B. ಯಾವ ಸೈಡ್ ಹೋಗುತ್ತೆ? It's in the northern hemisphere. Okay. A side or B side? A side or B side? B side. Why? In the northern hemisphere, right side. Illinda ನೋಡಿ. Right side means this one. Left side means this one. So B, right? That means the wind which started from here blow like this. Here. ತರ circle ತರ ಆಗಿದೆ. The wind which started from here blow like this. The wind which started from here blow like this. ಇಲ್ಲಿ ಸ್ಟಾರ್ಟ್ ಆಗಿದ್ದು ಹೀಗೆ ಬರುತ್ತೆ. Right? Then the wind which started from the pole, like ಇಲ್ಲಿಂದ the wind started ಇಲ್ಲಿಂದ ಇದು ಯಾವ ಕಡೆ blow ಆಗುತ್ತೆ? This is A, this is B. B side, right? Here it is also in the northern hemisphere, means wind started from here ಹೀಗೆ ಇಲ್ಲಿಂದ ಹೀಗೆ. That's why the name easterly, polar easterly ಕರೀತೀವಿ. right? Same thing. ಇಲ್ಲಿಂದ ಅಪ್ಲೈ ಮಾಡಿ. The wind we started from this place and going towards the equator. Where it will deflect? ಈ ಕಡೆ ಹೋಗುತ್ತಾ? ಈ ಕಡೆ ಹೋಗುತ್ತಾ? ಇಲ್ಲಿಂದ. This is A and this is B. Which side? B. Why? Coil is force and why B here? This is in the southern hemisphere. Southern hemisphere Coriolis force acts on the left side. That's why B. Here. The wind started here. This is A. This is B. A side or B side? A side because left means here. Right? The wind started from here. Goes like this. Same thing. Here. Here. Okay. The wind started here. Each This is how. This is called polar eastern. East side the east side polar. And hardness is all discuss ಮಾಡಿದ್ವಲ್ಲ ಅದರಲ್ಲಿ ಎಲ್ಲಿ ಬರುತ್ತೆ ಹೇಳಿ. See this is a ಇಲ್ಲ ಅಲ್ವಾ ಹೀಗೆ three different and this is one cell, second cell, third cell, fourth cell, fifth cell, sixth cell, total 6 cells and 7 pressure beds. Total 7 pressure beds. 1, 2, 3, 4, 5, 6, 7. Right? This is and this is the ITC. ITC means intratropical convergence zone. ಹೇಗೆ ಹೇಳಿ ಇಲ್ಲಿಂದ ವಿಂಡ್ ಬೀಸೋದು ಈಚೆ ಬರುತ್ತೆ, ಇಲ್ಲಿಂದ ವಿಂಡ್ ಬೀಸೋದು ಈಚೆ ಬರುತ್ತೆ. ಸೊ ಇದು ಕನ್ವರ್ಜ್ ಆಗುತ್ತೆ. ಇಲ್ಲಿ ಸಿ ಆನ್ ಈಕ್ವೇಟರ್ ದಿಸ್ ಇಸ್ ಈಕ್ವೇಟರ್ ವೆಸ್ಟರ್ಲಿ, ಈಕ್ವೇಟರ್ ಮೇಲಾಗಿರೋ ವಿಂಡು ಈ ಕಡೆ ಮೂವ್ ಆಗುತ್ತೆ, ಅರೈಸ್ ಆಗಿರೋ ವಿಂಡ್. ಬಟ್ ಈಚೆಯಿಂದ ಬಂದಿರೋ ವಿಂಡ್ ಈಚೆಯಿಂದ ಬಂದಿರೋ ವಿಂಡ್ ಈ ಸೈಡ್ ಮೂವ್ ಆಗುತ್ತೆ. ಓಕೆ, ಬಿಕಾಸ್ ಇಟ್ ವಿಲ್ ಕನ್ವರ್ಜ್ ಹಿಯರ್. ದಟ್ಸ್ ವೈ ದ ನೇಮ್ intratropical. This is the tropical area. This is the tropical area. It is in between two tropical areas. That's why the name intratropical convergence zone, ITCZ. At equator we experiences ITCZ. At equator we experiences ITCZ. That means intratropical convergence zone. Means this is also tropical region. This is also tropical region, and they will converge at the equator. I told you intra. Actually, inter in between two. Intra means within. This is ide bere. So inter, not intra. Intertropical convergence zone. This is intertropical convergence zone. Intertropical convergence zone in between these tropical. This is all. See, ಈ ಕಡೆ ಒಂದು ಗಾಳಿ ಬೀಸ್ತಾ ಇದೆ, ಈ ಕಡೆ ಒಂದು ಗಾಳಿ ಬೀಸ್ತಾ ಇದೆ. ಸೊ ಹೀಗೆ ಹೋಗುತ್ತೆ. ಅಂಡ್ ದಿಸ್ ಇಸ್ ದ ಈಕ್ವೇಟರ್. ಇಲ್ಲಿಂದ ಗಾಳಿ ಬೀಸ್ತಾ, ಇಲ್ಲಿಂದ ಗಾಳಿ ಬೀಸ್ತಾ, ಮೇಲ್ಗಡೆ ಹೋಗುತ್ತೆ. ಅಂಡ್ ಇನ್ ಬಿಟ್ವೀನ್ ದ ಪ್ಲೇಸ್ ಆನ್ ದ ಈಕ್ವೇಟರ್ ಆರ್ ಕಾಲ್ಡ್ ಡೋರ್ಡ್ರಮ್. ಮೀನ್ಸ್ ಏರ್ ಇರಲ್ಲ ಅಲ್ಲಿ. ದಟ್ಸ್ ಎಂಪ್ಟಿ ಸ್ಪೇಸ್, ಡೋರ್ಡ್ರಮ್. ಬಿಕಾಸ್ ಈಚಿಂದ ಬಂದಿರೋ ಗಾಳಿ ಈಚಿಂದ ಹೀಗೆ ಹೋಗ್ತಾ ಇರುತ್ತೆ. ಇನ್ ಬಿಟ್ವೀನ್ ಅ ನ್ಯಾರೋ ಏರಿಯಾ ಕಾಲ್ಡ್ ಡೋರ್ಡ್ರಮ್. DOL ಡೋರ್ಡ್ರಮ್. ಎಲ್ಲಿ ನೋಡಬಹುದು ಡೋರ್ಡ್ರಮ್ ಅಂತ ಹೇಳಿದ್ರೆ ಆನ್ ಈಕ್ವೇಟರ್. ಕ್ವಶನ್ ಅಲ್ಲಿ ಕೇಳಿದ್ದಾರೆ, ವೇರ್ ಡೋರ್ಡ್ರಮ್ ಲೊಕೇಟೆಡ್? ಇಟ್ ಲೊಕೇಟೆಡ್ ಆನ್ ಈಕ್ವೇಟರ್. ಡೋರ್ಡ್ರಮ್ ಮೀನ್ಸ್ no air area, the region of calm area, whatever, calm area, there is no air, nothing. That is on the equator normal. Okay. Yeah, ITCZ means where two trade winds meet. That place is called ITCZ. Equator ಮೇಲೆ ಇರಬೇಕಂತ ಇಲ್ಲ. Depending on the season ಇದು ಶಿಫ್ಟ್ ಆಗುತ್ತೆ. ಸಮ್ಮರ್ ಸೀಸನ್ ಅಲ್ಲಿ ಇದು ನಾರ್ತ್ ಸೈಡ್ ಬರುತ್ತೆ. ITCZ ಶಿಫ್ಟ್ ಟುವರ್ಡ್ಸ್ ನಾರ್ತ್ ಸೈಡ್ ಇನ್ ಸಮ್ಮರ್ and IT season shift towards south side in the winter. Okay, this IT season means the wind zero jaga, the wind of two trade winds where they converge. That area is called intertropical convergence. IT season. So this is not always on the equator. Sometimes the question is like IT season is always on the equator. Wrong. That is not always. Depending on the season, it shifts. That's why we get some rainfall. That's why we experience rainfall in the summer, like June, July, and winter in the December. IT season shift. Okay. IT season means normally direct sun rays elevated. Okay. The wind, different depending on how temperature, high temperature, pressure. Temperature always leads to pressure. So, what is the main reason wind movement? Pressure. High pressure to low pressure. And what is the main reason for the pressure? Temperature. And what is the reason for the temperature? Solar light. And solar light, depending on the season, it will differ. On a summer season, solar light on a 23 and half, Tropic of Cancer, yesterday we discussed it. On a winter, 23 and half south means Tropic of Capricorn. So, on a winter, on a summer, the IT season shifts towards north side. On a winter, IT season shift towards south side. Normal IT season ಅಂದ್ರೆ ಎರಡು ವಿಂಡ್ಸ್ ಸೇರೋ ಜಾಗ. ವಿಂಡ್ಸ್ ಯಾವಾಗ ಸೇರುತ್ತೆ? ವಿಂಡ್ಸ್ಗೆ ಏನು ಬೇಕು? ಪ್ರೆಷರ್ ಡಿಫರೆನ್ಸ್ ಬೇಕು. ಅಂಡ್ ಪ್ರೆಷರ್ಗೆ ಏನು ಬೇಕು? ಹೈ ಟೆಂಪರೇಚರ್ ಲೋ ಪ್ರೆಷರ್, ಲೋ ಟೆಂಪರೇಚರ್ ಹೈ ಪ್ರೆಷರ್ ಮೀನ್ಸ್ ಟೆಂಪರೇಚರ್ ಬೇಕು. ಟೆಂಪರೇಚರ್ಗೆ ಏನು ಬೇಕು? ಸನ್ ರೈಸಸ್ ಬೇಕು. ಸನ್ ರೈಸಸ್ ಡೈರೆಕ್ಟ್ ಆಗಿ ಯಾವಾಗ ಬೀಳುತ್ತೆ? ಈಕ್ವೇಟರ್ ಮೇಲೆ ಮಾರ್ಚ್ 21st, ಅದು ಬಿಟ್ಟರೆ ಸೆಪ್ಟೆಂಬರ್ 22nd. ಅಂಡ್ ಇನ್ ಬಿಟ್ವೀನ್ ಏಪ್ರಿಲ್ ಮೇ ಜೂನ್ 22nd ಎಲ್ಲಿ ಬರುತ್ತೆ? ಟ್ರಾಪಿಕ್ ಆಫ್ ಕ್ಯಾನ್ಸರ್ ಮೇಲೆ ನಿನ್ನೆ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ. ಸೊ ಟ್ರಾಪಿಕ್ ಆಫ್ ಕ್ಯಾನ್ಸರ್ ಮೇಲೆ ಡೈರೆಕ್ಟ್ ಸನ್ಲೈಟ್ ಬೀಳ್ತಿದೆ ಅಂತ ಹೇಳಿದ್ರೆ ದಿಸ್ IT season shifted towards tropic of cancer. That is not on the equator on that day. On June 22nd or June 21st, whatever, the IT season shift on towards tropic of cancer. Or it is on the tropic of cancer, not on the equator, because IT season means where directly sun rays are falling. ಅದು ಮಾತ್ರ ಇದು ಎರಡು ಸೇರೋದು. ಅದರಿಂದ ಬೇರೆ ಕನೆಕ್ಷನ್ ಇದೆ. ಸನ್ ರೈಸಸ್ ಇಂದ ಟೆಂಪರೇಚರ್ ಕನೆಕ್ಷನ್ ಇದೆ, ಟೆಂಪರೇಚರ್ ಇಂದ ಪ್ರೆಷರ್ ಕನೆಕ್ಷನ್ ಇದೆ, ಪ್ರೆಷರ್ ಇಂದ ವಿಂಡ್ ಕನೆಕ್ಷನ್ ಇದೆ. ದಟ್ ಈಸ್ ಹೌ. ಅರ್ಥ ಆಯ್ತಾ ಕಾನ್ಸೆಪ್ಟ್? ನಿನ್ನೆ ಕ್ಲಾಸ್ ಕೇಳಿದ್ರೆ ಸ್ವಲ್ಪ ಕಷ್ಟ ಇದೆ, ಇನ್ನೊಂದು ವಿಡಿಯೋದಲ್ಲಿ ನೋಡಿ. ಓಕೆ, ದಿಸ್ ಇಸ್ ಹೌ. ಸೊ IT season is not always on the equator, that is depending on the season. Okay, this is all. Take a note. Take IT season as a separate. It is a low pressure area. Due to high temperature associated with solar radiation. Associated with solar radiation. See, this 0 degree equator ಅಂತ ಅನ್ಕೊಂಡ್ರೆ ಈ ಕಡೆ ನಾರ್ತ್ ಸೈಡ್ ಇಂದ ಬಂದಿರೋ ಮತ್ತೆ ಸೌತ್ ಸೈಡ್ ಇಂದ ಬಂದಿರೋ ಬೆಂಡಿಂಗ್ ಈಕ್ವಲ್ ಹೋಗುತ್ತೆ. ಈ ಖಾಲಿ ಎಂಟಿ ಏರಿಯಾ ಇದೆಯಲ್ಲ, ದಿಸ್ ಇಸ್ ದ ಡೋಲ್ ಡೌನ್. ಓಕೆ, due to high temperature associated with solar radiation. Full stop. Within IT season, we observe a region of calm. Within IT season, we observe a region of calm. CALM, calm. Within IT season, we observe a region of calm known as doldrum. Within IT season, we observe a region of calm known as doldrum. In this region, air moves from west to east. Why air move from west to east within doldrum? Within doldrum means it is on an equator, means middle of the earth. And I told you air move from west to east. The reason here is rotation of the earth. Earth rotates in west to east, right? ಅದರ ಜೊತೆಗೆ air movement ಆಗುತ್ತೆ because of the rotation of earth. In this region, air moves from west to east along with the rotation of Earth, and it is known as equatorial westerlies. It is known as equatorial westerlies. Okay. And take this as a side heading: subtropical high pressure. Subtropical high pressure. Both subtropical high pressure. How many subtropical high pressure on Earth? 2. Okay. Dynamically induced pressure belt. See, I told you dynamically induced means what? This is not thermally induced. This is not because of high temperature. This is because of high pressure. Right? High pressure, descending air. Right? Dynamically induced pressure belt in between Hadley cell and Ferrel cell. In between Hadley cell and Ferrel cell. Now previous diagram, Hadley cell and Ferrel cell. Descending air in the region, in this region, descending air in this region has led to, descending air in this region has led to tropical deserts. Tropical deserts. It is also known as harsh latitude. It is also known as harsh latitude. Next, subpolar low pressure. Subpolar low pressure. Subpolar low pressure. Is this thermal induced or dynamical induced? Subpolar low pressure. Thermally induced. Wait, thermally induced low pressure area. Thermally induced low pressure area between Ferrel cell and polar cell. Right? Between Ferrel cell and polar cell. Ferrel, F-E-R-R-E-L, Ferrel cell and polar cell. Due to convergence, we observe temperate cyclones. See, ನೋಡಿ ಈ ಕಡೆಯಿಂದ ಗಾಳಿ ಬೀಸ್ತಾ ಇರುತ್ತೆ, ಈಚೆಯಿಂದ ಹೀಗೆ ಗಾಳಿ ಬೀಸ್ತಾ ಇರುತ್ತೆ, ಇಲ್ಲಿಂದ ಹೀಗೆ ಆದಾಗ ಇಲ್ಲೊಂದು ಸರ್ಕಲ್ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತಲ್ಲ, ಇನ್ ಬಿಟ್ವೀನ್ ಏರ್ ಸರ್ಕಲ್, ಅದರಿಂದ ಸೈಕ್ಲೋನ್ ಫಾರ್ಮೇಷನ್ ಆಗುತ್ತೆ. ಸೊ ಟ್ರಾಪಿಕಲ್ ಏರಿಯಾದಲ್ಲಿ ಟೆಂಪರೇಟ್ ಸೈಕ್ಲೋನ್ಸ್ ಜಾಸ್ತಿ ಸಿಗುತ್ತೆ. ಐ ಮೀನ್ ಇಲ್ಲಿ ಈ ವಿಂಡ್ ಡೈರೆಕ್ಷನ್ ಇಂದ ಸೈಕ್ಲೋನ್ಸ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ. ಅದೇ ಸೈಕ್ಲೋನ್ ಮಾಡೋದು ಅಲ್ಲೂ ಅಷ್ಟೇ ಮೇಲ್ಗಡೆ ಹೀಗೆ ಇದು ಹೀಗೆ. Temperate cyclones in this region also. Then polar high pressure as a subheading. Polar high pressure. Dynamically induced high pressure area, which leads to cold desert. Take Hadley cell as a subheading. Hadley cell here. Hadley cell, H-A-D-L-E-Y. In between subtropical high pressure and ITCZ. In between subtropical high pressure and ITCZ, we observe Hadley cell. In northern hemisphere, surface winds are northeast trade winds. In northern hemisphere, surface winds are northeast trade winds. Normally I told you, the winds gets its name from where it arises. I told you, in northern hemisphere, we are talking about this region, right? Hadley cell means this region. subtropical high pressure area to equatorial area or ITCZ area. Hadley cell means, see, I'll clear this. ಅವಾಗ ನೆನಪಿಟ್ಕೋಬೇಕು, ಈ ಹೈಡ್ಲೆ ಸೆಲ್ ಅಥವಾ ಫೆರಲ್ ಸೆಲ್ 0 ಡಿಗ್ರಿ to 30 ಡಿಗ್ರಿ ಅನ್ನೋಕ್ಕಿಂತನೂ it is between the ITCZ to subtropical high pressure area. What is the difference between 0 degree and ITCZ and 30 degree and subtropical high pressure area? 30 degree and 0 degree are the constant, ಅಲ್ಲೇ ಇರುತ್ತೆ. 30 degree ಮತ್ತೆ 0 degree ಅಲ್ಲೇ ಇರುತ್ತೆ. But this subtropical high pressure area and this ITCZ may shift depending on the seasons. Sun rays ಬೇರೆ ಕಡೆ ಬಿದ್ದಾಗ ಶಿಫ್ಟ್ ಆಗುತ್ತೆ. So wind movement ಕೂಡ ಶಿಫ್ಟ್ ಆಗುತ್ತೆ. Right? So that is not constant. ITCZ and subtropical high pressure area is not constant. Depending on that, you are right. Okay, I told you in this region, Hadley cell ಅಂತ ಹೇಳಿ, Hadley cell is not constant. ಆಚೆ ಈಚೆ ಆಗ್ತದೆ because Hadley cell is a atmospheric phenomena, not a geological phenomena. Atmospheric 0 degree and 30 degree is geographic, it's geographical phenomena, geological, right? And this is the Hadley cell region ಅಂತ ಹೇಳಿದೆ. And in the Hadley cell we experiences north eastern trade winds ಅಂತ ಹೇಳಿದೆ. North eastern trade winds. ಹೌದಲ್ವಾ? ಇಲ್ಲಿಂದ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. ಇಲ್ಲಿಂದ ಸ್ಟಾರ್ಟ್ means what? North side. This is north side. And eastern side, it going towards west. It going towards west means it starts from east. Right? So the north eastern trade winds. Okay, in the northern hemisphere. In the southern hemisphere the pattern is different. In the southern hemisphere, south eastern trade winds. In the northern hemisphere, north eastern trade winds. Right? Within the Hadley cell. Alva. In the northern hemisphere, surface winds are northeast trade winds, and in the southern hemisphere it is southeast trade winds. Badla. And in the southern hemisphere it is southeast trade winds. In the southern hemisphere it is southeast trade winds. Next, take heading as a feral cell. FERREL. Feral cell ಬರುತ್ತೆ. Feral cell normally ನಾವು ಹೇಳುವಾಗ 30 degree to 60 degree ಹೇಳ್ತೀವಿ, but instead of that we can say like it is in between subtropical high pressure area to subpolar low pressure area, right? Hadley cell situates in between, right? Hadley cell, feral cell, not Hadley cell, feral cell situates in between, are present in between subtropical high pressure area to subpolar low pressure area. Connect and write, don't write blindly. See, subtropical, STHP, subtropical high pressure area to subpolar low pressure, STHP, subpolar low pressure area. This region. See, this is not a trade wind. Trade wind alva. It is the region of westerly, right? It is the region of westerly. Westerlies are surface winds here. Westerlies are the surface winds here. And the northern hemisphere westerlies are slower. Nidana reason. Northern hemisphere westerly. Slower than southern hemisphere westerly. ಯಾಕೆ ಇಲ್ಲೂ southern westerlies ಇದೆ, ಇಲ್ಲೂ westerlies ಇದೆ, but northern hemisphere westerlies are slower and southern hemisphere westerlies are grow very faster. Why? Southern hemisphere had oceans, so there is no barrier for the flow. In northern hemisphere there is a land, because of that there is lot many barriers. In the southern ocean there is no land, nothing on the ocean, so the speed of the westerly is very faster in southern hemisphere. The speed of the westerly in the northern hemisphere is comparatively slow, right? In southern hemisphere it is known as, because of this reason, in southern hemisphere it is known as, in southern hemisphere this is known as roaring 40s. Roaring 40s. Roaring 40s. ROARING, roaring 40s, FORTIS. And furious 50s. Furious 50s means 50 km per hour speed of ಹೋಗ್ತಾ ಇದೆ, ಅದನ್ನ furious 50s ಅಂತ ಕರೀತಾರೆ. FURIOUS 50s. FIFTAS, 50s. If it is in the 60s, ಶ್ರೈಕಿಂಗ್ 60s. ಶ್ರೈಕಿಂಗ್ 60s. ಈ ವರ್ಡ್ಸ್ ಅನ್ನೆಲ್ಲ ಕೊಟ್ಟು ಕೇಳ್ಬೋದು. ಶ್ರೈಕಿಂಗ್ SCHRIECKING. ಶ್ರೈಕಿಂಗ್ 60s. SIXPIES. Okay, this is it. Then I ask like ಇದು ಒಂದ್ಸತಿ ಯಾವುದೋ ಎಕ್ಸಾಂಪಲ್ ಕೇಳಿದ್ದಾರೆ. roaring 40s or furious 50s or shaky 60s is related to which wind ಅಂತ? Related to the first option is westerly, second option is northern westerly, third option is southern westerly. Southern westerly, right? Not trade winds. Trade winds ಅಂತ ಹೇಳಿದ್ರೆ ಇಲ್ಲಿ ಬರುತ್ತೆ ಇದು. ಹ್ಯಾಂಡ್ಲಿಸ್ ಎಲ್ಲ ಬರೋದು trade winds. ಫೆರಲ್ಸ್ ಎಲ್ಲ ಬರೋದು westerlies, right? Next, polar cell. Take it as a polar cell. Polar cell. In between subpolar low pressure. In between subpolar low pressure and polar high pressure. Polar high pressure. We observe polar cell. These winds brings snowfall from polar region. Brings snowfall from polar region. See, these winds arises from the pole and move towards equator, right? ಇಲ್ಲಿಂದ ಸ್ಟಾರ್ಟ್ ಆಗಿ ಈ ಕಡೆ ಬರುತ್ತೆ, ಈ ಕಡೆಯಿಂದ ಸ್ಟಾರ್ಟ್ ಆಗಿ ಆ ಕಡೆ ಹೋಗಲ್ಲ. ಯಾಕೆ? Wind always blow from high pressure to low pressure. Here is low temperature, means high pressure. Pole low, very low temperature compared to equator side. Low temperature means high pressure, and wind always blow from high pressure to low pressure. That's why there is no movement of wind from here to here. There is always movement of wind from here to here. That's why along with the wind, this also brought some snow. Snow. Hi. This is how. From the beginning, ಎಲ್ಲರನ್ನು ನಮ್ಮ ನಾಲೆಡ್ಜ್ ಕಲ್ತಿರೋದ್ರಿಂದ ಇನ್ಸರ್ಟ್ ಮಾಡಿ. This is the entire weight of the earth. Over. Just revise ಮಾಡಿ. ಏನಾದರೂ ಡೌಟ್ಸ್ ಬಂದ್ರೆ ಈಗಲೇ ಕೇಳಿ. ಜೂನ್ ಫಸ್ಟಿಗೆ ಕೇರಳ ಕೋಸ್ಟಿಗೆ ವಿಂಡ್ ಬಂದು ಆನ್ ಏನು ಹೇಳ್ತೀವಿ ನಾವು ಅದಕ್ಕೆ ಆನ್ ಶೋರ್ ವಿಂಡ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಜೂನ್ ಫಸ್ಟಿಗೆ ಕೇರಳ ಕೋಸ್ಟಿಗೆ ಬರುತ್ತೆ, ಅರೌಂಡ್ ಕರ್ನಾಟಕ ಜೂನ್ 10ಗೆ ಬರುತ್ತೆ, ಅರೌಂಡ್ ಜುಲೈ ಅಷ್ಟೊತ್ತಿಗೆ ಮಹಾರಾಷ್ಟ್ರ ಮಧ್ಯಪ್ರದೇಶದಲ್ಲಿ, ನವೆಂಬರ್ ಡಿಸೆಂಬರ್ ಪಂಜಾಬ್ ಅಲ್ಲಿ. ಸೊ ದಿಸ್ ಇಸ್ ವಿಂಡ್ ಅಲ್ವಾ. ಸೊ ವಿಚ್ ವಿಂಡ್ ಇಟ್ ಇಸ್? ವೆಸ್ಟರ್ಲಿ ದ ಪೋಲಾರ್ ಈಸ್ಟರ್ಲಿ ಇಂಡಿಯಾದಲ್ಲಿ India around 33 degree means it is a tropical region or in between tropical and temperate. Tropical region. It is not in a polar region. That means it is not a polar easterlies first of all. And India, the main rainfall will not get because of the westerlies. Westerlies in the rainfall in India. Westerly experiences ಇದೆ ಅಂದ್ರೆ in some regions of the Punjab or in some regions of the J&K, because of westerlies influences in some of these seasons, like in winter, ondistu snowfall kind of situation arises. That is different. But majority of mainland India gets rainfall because of which kinds of wind? Trade winds. Indian mainland gets rainfall because of trade winds. Okay? What is monsoon? India depending on monsoon. Our school is Indian agriculture, monsoon depending agriculture. Indian agriculture depending on monsoon. Alva? What is monsoon then? Monsoon then? Monsoon is nothing but changing the direction of the wind. That's it. Something monsoon means wind direction change ಆಗ್ತಿದೆ ಅಂತ. Normal like what is the direction? This is the direction. This is the geographical direction and it should be like this only. ಹೀಗೆ ಇರಬೇಕು. If something changes this direction, the wind, trade winds ಅಂತ ಹೇಳಿದ್ರೆ ಅದು ಈಸ್ಟ್ ಇಂದನೇ ಸ್ಟಾರ್ಟ್ ಆಗಬೇಕು ಅಲ್ವಾ. Here south eastern trade winds. This is south eastern trade winds, right? This is north eastern trade winds. Means south trade winds means it should start from the east only. It should blow from the east towards west only. And westerlies means it should start from west to east only. It should start from west and blow towards east only. Means this is the standard one. Something which changes wind direction is that is monsoon. So India is monsoon depending. India experiences rainfall because of monsoon. Or Indian rainfall depends on monsoon. ಅಂತ ಹೇಳಿದ್ರೆ ಏನಾಗುತ್ತೆ? ಯಾವ ವಿಂಡ್ ಡೈರೆಕ್ಷನ್ ಚೇಂಜ್ ಮಾಡಿಕೊಂಡು ಇಂಡಿಯಾದಲ್ಲಿ ರೈನ್ಫಾಲ್ ಬರುತ್ತೆ. ಇಂಡಿಯನ್ ರೈನ್ಫಾಲ್ ಡಿಪೆಂಡಿಂಗ್ ಆನ್ ಮಾನ್ಸೂನ್ ಮೀನ್ಸ್ ಯಾವುದೋ ವಿಂಡ್ ಡೈರೆಕ್ಷನ್ ಚೇಂಜ್ ಆಗಿ ಮಾನ್ಸೂನ್ ಈ ಕಡೆ ಬರ್ತಾ ಇದೆ. ವಿಂಡ್ ಮೀನ್ಸ್ ವಾಟ್? ದಟ್ ಇಸ್ ವಾಟ್ ದಿ ಕ್ಲೌಡ್, ದಟ್ ಇಸ್ ವಾಟ್ ದಿ ರೈನ್ಫಾಲ್. ವಿಂಡ್ ಇಸ್ ದಿ ಮೇನ್ ರೀಸನ್ ಫಾರ್ ದಿ ರೈನ್ಫಾಲ್, ರೈಟ್? ಹಾಗಾದ್ರೆ ಯಾವ ವಿಂಡ್? ಸಿ ಇಲ್ಲಿ ನಾರ್ತ್ ಈಸ್ಟ್ ಟ್ರೈಡ್ ವಿಂಡ್ಸ್ ಇದೆ. ದಿಸ್ ಇಸ್ ಇಂಡಿಯಾ. ಓಕೆ, ಈ ರೀಜನ್ ಬರುತ್ತೆ. ನಾರ್ದರ್ನ್ ಹೆಮಿಸ್ಫಿಯರ್ ಅಂಡ್ ಈಸ್ಟರ್ನ್ ಹೆಮಿಸ್ಫಿಯರ್ ಈ ರೀಜನ್ ಬರುತ್ತೆ. ನಾರ್ತ್ ಈಸ್ಟ್ ಬರುತ್ತೆ, ಇಲ್ಲಿ ಬರುತ್ತೆ. ಓಕೆ, ದಿಸ್ ಇಸ್ ಇಲ್ಲಿ ರೈನ್ಫಾಲ್ ಆಗೋದು ನಾಟ್ ಬಿಕಾಸ್ ಆಫ್ ವೆಸ್ಟರ್ಲೀಸ್ ಫಸ್ಟ್ ಆಫ್ ಆಲ್, ಅಂಡ್ ನೈದರ್ ಬಿಕಾಸ್ ಆಫ್ ವೆಸ್ಟರ್ಲೀಸ್, ನಾಟ್ ಬಿಕಾಸ್ ಆಫ್ ನಾರ್ತ್ ಈಸ್ಟ್ ಟ್ರೇಡ್ ವಿಂಡ್ಸ್. ನಮಗೆ ಅನ್ಸುತ್ತೆ ಈ ನಾರ್ತ್ ಈಸ್ಟ್ ಟ್ರೇಡ್ ವಿಂಡ್ಸ್ ಇದೆ ಇದರಿಂದ ರೈನ್ಫಾಲ್ ಆಗುತ್ತೆ. ನೋ, ದ ಮೇಜರ್ ರೈನ್ಫಾಲ್ ಫಾರ್ ಇಂಡಿಯಾ ಬಿಕಾಸ್ ಆಫ್ ದಿಸ್ ಸದರ್ನ್ ಸೈಡ್ trade winds. Southern side trade winds, it crosses equator and it changes its direction towards east and it comes over Indian mainland and then it gives rainfall. The reason because of its shift is crossing the equator and the wind changes its direction. That's why this wind is called monsoon. So monsoon means something changing direction. Because of that, India experiencing monsoon rainfall. India ಮಳೆ ಬರೋದು ಈ ವಿಂಡ್ ಇಂದ, ಸೌತ್ ಈಸ್ಟರ್ನ್ ಟ್ರೇಡ್ ವಿಂಡ್ಸ್ ಇಂದ. When south eastern trade winds crosses equator and it will become south western trade winds, right? West side ಇಂದ ಈಸ್ಟ್ ಸೈಡ್ ಹೋಗೋದು. ಹೀಗೆ ಬಂದಿರೋ ವಿಂಡ್ ಇಲ್ಲಿ ಈಕ್ವೇಟರ್ ಕ್ರಾಸ್ ಮಾಡಿ ಈಚೆ ಹೋಗುತ್ತೆ. ಈಚೆ ಹೋದ್ಮೇಲೆ ಹೇಗೆ ಹೋಗ್ಬೇಕು? ಸೌತ್ ವೆಸ್ಟರ್ನ್ ಟ್ರೇಡ್ ವಿಂಡ್ಸ್ ಆಗಿ ಹೋಗಿ Indian ಮೇಲೆ ಬರುತ್ತೆ. That's why India experiences monsoon rainfall. Monsoon means changing wind, changing the direction of the wind. the direction, the wind which is giving rainfall to the India, it changed its direction previously and come over India. That's why the name monsoon. And that is started as a southeastern trade wind, and after crossing equator, it shifted its direction towards southeastern. Okay, that's what I mean. Southwestern. Always wind names start from where it comes from. So southwestern, from the west side to east side. Southwestern. ಅದಕ್ಕೆ ನಮಗೆ ಏನಿದೆ ಬರೋದು ಫಸ್ಟ್ ಕೋಸ್ಟ್ ನಮಗೆ ಈಚೆಯಿಂದ ಮಳೆ ಬರೋದಲ್ಲ, ಫಸ್ಟ್ ಇಲ್ಲಿ ಕೇರಳ ಕೋಸ್ಟ್, ನಾಟ್ ಫ್ರಮ್ ದಿ ಈಸ್ಟರ್ನ್ ಕೋಸ್ಟ್ ಇಂದ ನಮಗೆ ಮಳೆ ಸ್ಟಾರ್ಟ್ ಆಗೋದಲ್ಲ, ವೆಸ್ಟರ್ನ್ ಕೋಸ್ಟ್ ಇಂದ ನಮಗೆ ಮಳೆ ಸ್ಟಾರ್ಟ್ ಆಗೋದು. ಕೇರಳದಿಂದ ಫಸ್ಟ್ ಮಳೆ ಜೂನ್ 21 ಇಲ್ಲಿ ಕ್ಲೌಡ್ ಸ್ಟಾರ್ಟ್ಸ್ ಇಲ್ಲಿಂದ, ದೆನ್ ಹೀಗೆ ಮೇಲೆ ಹೋಗುತ್ತೆ. ದಿಸ್ ಇಸ್ ಆಲ್. ಓಕೆ, ಮೈ ಕ್ವೆಶ್ಚನ್ ಇಸ್ ಯಾಕೆ ಇದನ್ನೆಲ್ಲ ಚೇಂಜ್ ಆಗಿ ಈ ಕಡೆ ಬರುತ್ತೆ? ಇಲ್ಲೇ ಇರ್ಬೋದಿತ್ತಲ್ಲ ಮೂಮೆಂಟ್, ಮೇಲೆ ಯಾಕೆ ಬರುತ್ತೆ? That is what I told you, the shifting of ITCZ. India experiences rainfall in summer. Yesterday I told you, there is no rainy season. According to geographer, there are only two seasons, only summer and another one is winter. And India experiences summer in June 21st. India experiences summer in June 21st means what? Yesterday class. June 21st, what happens? Sun rays is directly falling in a Tropic of Cancer. 23.5. When sun rays is directly falling in a Tropic of Cancer means ITCZ is at Tropic of Cancer, not on equator. ITCZ means what? Trade winds meet over jaga. Trade winds meet over jaga. June 21st ಗೆ 23.5 north side ಇರುತ್ತೆ, means Tropic of Cancer ಮೇಲೆ ಇರುತ್ತೆ ITCZ, because sun rays are directly falling in a Tropic of Cancer on June 21st, and that is the time of India's rainfall. ಇಲ್ಲಿ ITCZ ಇಲ್ಲಿ ಶಿಫ್ಟ್ ಆದಾಗ ಮೀನ್ಸ್ ಇಂಡಿಯಾ ಮೇಲೆ ಶಿಫ್ಟ್ ಆದಾಗ ಎಂಟೈರ್ ಇದೇ ಮೇಲೆ ಹೋಗುತ್ತಲ್ವಾ, ಮೀನ್ಸ್ ಟ್ರೇಡ್ ವಿಂಡ್ಸ್ ಆಫ್ ದಿ ಸೌತ್, ಐ ಮೀನ್ ಸದರ್ನ್ ಟ್ರೇಡ್ ವಿಂಡ್ಸ್ ಬಿಕಮ್ ಹೀಗೆ, ಐ ಮೀನ್ ಸೌತ್ ಈಸ್ಟರ್ನ್ ಟ್ರೇಡ್ ವಿಂಡ್ಸ್ ಬಿಕಮ್ ಸೌತ್ ವೆಸ್ಟ್ ಆಫ್ಟರ್ ಕ್ರಾಸಿಂಗ್ ಈಕ್ವೇಟರ್ ಹೀಗೆ ಬರುತ್ತೆ. ಇಲ್ಲಿರೋದು ಮೇಲ್ ಬರುತ್ತೆ, ದೆನ್ ಆಫ್ಟರ್ ಕ್ರಾಸಿಂಗ್ ಈಕ್ವೇಟರ್ ಇಟ್ turns towards eastern side and it will become southwestern trade winds. Before it is a southeastern trade winds in the southern hemisphere. After crossing equator, it will become southwestern trade winds and move towards over India, on the mainland of India. Okay, this is all. This is because of ITCZ shift. And after that, again, September 22nd, again equinox. Equinox means sun rays is directly falling on the equator. That is equinox. Matte same. ಟ್ರೇಡ್ ವಿಂಡ್ಸ್ ಇಲ್ಲೇ ಬರುತ್ತೆ, ಅವಾಗ ಇಲ್ಲೂ ಮಳೆ. ಅಗೇನ್ ಡಿಸೆಂಬರ್ 22nd ಏನಾಗುತ್ತೆ? ಸನ್ ರೈಸ್ ಇಸ್ ಡೈರೆಕ್ಟ್ಲಿ ಫಾಲಿಂಗ್ ಆನ್ ಟ್ರಾಪಿಕ್ ಆಫ್ ಕ್ಯಾಪ್ರಿಕಾರ್ನ್ ಮೀನ್ಸ್ 23 ಡಿಗ್ರಿ ಸೌತ್. ಅವಾಗ ಏನಾಗುತ್ತೆ? ಎಂಟೈರ್ ಸೆಟ್ ಕೆಳಗೆ ಬರುತ್ತೆ. ಅವಾಗ ಏನಾಗುತ್ತೆ? ನಾರ್ತ್ ಈಸ್ಟರ್ನ್ ಟ್ರೇಡ್ ವಿಂಡ್ಸ್ ಎಲ್ಲ ನಾರ್ತ್ ವೆಸ್ಟರ್ನ್ ಟ್ರೇಡ್ ವಿಂಡ್ಸ್ ಆಗಿ ಈಚೆ ಅವಾಗ ಇಲ್ಲಿರೋ ಒಂದಿಷ್ಟು ಕಂಟ್ರಿ ಮಳೆ ಬರುತ್ತೆ. ಓಕೆ, ದಿಸ್ ಇಸ್ ಆಲ್. Okay, so India experiences rainfall not because of north trade winds, it is because of south trade winds. Maybe India is in the northern hemisphere, but India's major rainfall is because of southern easterlies. So, or southern, not easterlies, southern trade winds. Southern trade winds. Okay, after crossing equator, it comes over India as a southwestern trade winds. Okay, ಇದನ್ನ ನಿಮ್ಮ ಸ್ಟೈಲಲ್ಲಿ ಬರ್ಕೊಳ್ಳಿ ಏನಂತ ಇರ್ತಲ್ಲ. This is the reason for India's rainfall. Then retreating monsoon ಅಂತ ಇದೆ. ಜೂನಿಗೆ ಸ್ಟಾರ್ಟ್ ಆಗಿದ್ದು ವಾಪಸ್ ಹೋಗಿ ಡೆಲ್ಲಿ ತನಕ ಹೋಗಿ ರೀಚ್ ಆಗಿ ಪಾಕಿಸ್ತಾನ ಬಾರ್ಡರ್ ತನಕ ಹೋಗಿ ಮತ್ತೆ ವಾಪಸ್ ಬರುತ್ತೆ. ಇವಾಗ ಪಾಕಿಸ್ತಾನಕ್ಕೆ ಹೋಗಲ್ಲ, ಕರೆಕ್ಟ್ ಬಾರ್ಡರ್ ಮೇಂಟೈನ್ ಮಾಡ್ತಾರೆ, ಮತ್ತೆ ವಾಪಸ್ ಬರುತ್ತೆ. ವಾಪಸ್ ಬರುವಾಗ ಈ ಸೈಡ್ ಈಸ್ಟರ್ನ್ ಕೋಸ್ಟ್ ಮಳೆ ಆಗುತ್ತೆ. ದಟ್ ಇಸ್ ರಿಟ್ರೀಟಿಂಗ್ ಮಾನ್ಸೂನ್. ಡ್ಯೂರಿಂಗ್ ವಿಂಟರ್ ಸೀಸನ್ ಅಲ್ಲಿ ನಮಗೆ ನಮ್ದು ಈಸ್ಟರ್ನ್ ಕೋಸ್ಟ್ ಅಲ್ಲಿ ಮಳೆ ಕಾಣುತ್ತೆ. ಈಸ್ಟರ್ನ್ ಕೋಸ್ಟ್ ಈಚೆಯಿಂದ ವಿಂಡ್ ಬೀಸುವಾಗ it gets vapors or water vapors ಎಲ್ಲಿಂದ ಸಿಗುತ್ತೆ? ಬೇ ಆಫ್ ಬೆಂಗಾಲ್ ಇಂದ ಸಿಗುತ್ತೆ. ಈಚೆಯಿಂದ ಬರುವಾಗ ಬೇ ಆಫ್ ಬೆಂಗಾಲ್ ಇಂದ ವಾಟರ್ ವೇಪರ್ ತಗೊಂಡು ಮಾಯಿಶ್ಚರ್ ಕ್ಯಾರಿ ಮಾಡಿ ಸಮ್ ಆಫ್ ದಿ Tamil Nadu area, some of the areas of the Andhra Pradesh, the two coastal areas of the Andhra Pradesh, coastal areas of the Tamil Nadu gets rainfall during winter season because of retreating monsoon. Retreating means ವಾಪಸ್ ಬರ್ತಾರೆ ಗೊತ್ತಾ ಈ ಕಡೆ ಹೋಗಿರೋ winds. Then after ಸೆಪ್ಟೆಂಬರ್ ಡಿಸೆಂಬರ್ ಏನಾಗುತ್ತೆ ಸೆಟ್ ಕೆಳಗೆ ಹೋಗುತ್ತೆ ನಾವು ವೈ ಡಿಸೆಂಬರ್ ಸೆಟ್ ಕೆಳಗೆ ಹೋಗೋದು ಯಾಕೆ ಅಥವಾ ಸೆಪ್ಟೆಂಬರ್ ಕೆಳಗೆ ಹೋದಾಗ ಐಟಿ ಸೀಸನ್ ಶಿಫ್ಟ್ ಆಗಿದೆ ಐಟಿ ಸೀಸನ್ ಅಗೇನ್ ಈಕ್ವೇಟರ್ ಮೇಲೆ ಇದೆ ಇವಾಗ ಸೆಪ್ಟೆಂಬರ್ 22ಗೆ ಐಟಿ ಸೀಸನ್ ಈಕ್ವೇಟರ್ ಮೇಲೆ ಇದೆ ಅವಾಗ ಎಂಟೈರ್ ಸೆಟ್ ಕೆಳಗೆ ಬರುತ್ತೆ ವಿಂಡ್ಸ್ ಕೆಳಗೆ ಬರುವಾಗ ಏನಾಗುತ್ತೆ ಈ ಮೇಲ್ಗಡೆ ಹೋಗಿರೋ ವಿಂಡ್ ಕೆಳಗೆ ಬರುವಾಗ it carries its it brings some moisture from the Bay of Bengal and it gives rainfall in a eastern coast of India like Tamil Nadu and some parts of Andhra Pradesh also Bengal. That is because of retreating monsoon. So India gets majority of its rainfall because of this southwestern trade winds and some of little amount of rainfall due to retreating monsoons. Okay, retreating monsoons are the northeastern trade winds. It starts from the north and east side. Okay, this is how things generally work. But majority of the rainfall because of southwestern trade winds only. Majority of Indian rainfall because of southwestern trade winds. India northern hemisphere ಇದ್ರೂ ಕೂಡ ಅದಕ್ಕೆ ಜಾಸ್ತಿ ಮಳೆ ಬರೋದು southwestern trade winds ಇಂದ. And southwestern trade winds is not western actually, that is a southeastern trade winds. After passing equator, it becomes southwestern. It means it changes its direction. That something changes its direction, right? That's why the name monsoon carries it. Okay, this is how. ಅದನ್ನು ಸುಮ್ಮನೆ ಇನ್ನೂ ಡಯಾಗ್ರಾಮ್ ಹಾಕಿ ಬರ್ಸಿದ್ರೆ ಟೈಮ್ ಎಷ್ಟು ಲೈಕ್ ಬರ್ಸ್ಬೋದು ಸಮ್ಮರ್ ಅಲ್ಲಿ ಹೀಗಿರುತ್ತೆ ಈಕ್ವಿನಾಕ್ಸ್ ಅಲ್ಲಿ ಹೀಗೆ ನಿಮ್ಮ ಸಿಚುವೇಶನ್ ಗೊತ್ತಾಯ್ತಲ್ವಾ ಬೇಕಾದ್ರೆ ಮನೆ ಹೋಗಿ ಅದು ಬರೀರಿ ಸಮ್ಮರ್ ಅಲ್ಲಿ ದಿಸ್ ಇಸ್ ದ ಸಿಚುವೇಶನ್ ದಿಸ್ ಇವಾಗ ಹೀಗಿದೆಯಲ್ಲ ದಿಸ್ ಇಸ್ ಸಿಚುವೇಶನ್ ಆಫ್ ಜೂನ್ 21st and September 22nd ಸಾರಿ ಮಾರ್ಚ್ 21st and September 22nd this is the situation of and on June 22nd ಏನಾಗುತ್ತೆ June 21st ಏನಾಗುತ್ತೆ ಈ ಐಟಿ ಸೀಸನ್ ಇಲ್ಲಿಗೆ ಹೋಗಿದೆ then on December 22nd ಇಲ್ಲಿಗೆ ಬಂದಿದೆ March ಮತ್ತೆ September this is the situation. Okay, when IT season shift towards tropic of Cancer ಏನು ಕರಿತೀವಿ IT season is on the tropic of Cancer. That is called summer solstice. Summer solstice. SOLSTICE. Summer solstice. So this is very important. SOLSTICE means IT season is on the Tropic of Cancer. ಇಲ್ಲಿರೋ IT season ಇಲ್ಲಿಗೆ ಬಂದ್ರೆ ಅದನ್ನ summer solstice ಅಂತ ಕರಿತೀವಿ. ಇಲ್ಲಿರೋ IT season ಇಲ್ಲಿಗೆ ಬಂದ್ರೆ means 23.5 degrees south means if the IT season is on the Tropic of Capricorn, then that is called winter solstice. Means winter level, December 22nd. That's why winter solstice. Okay. Lunch break ತಗೊಳ್ಳೋಣ ಎಷ್ಟೊತ್ತಿಗೆ ಸ್ಟಾರ್ಟ್ ಮಾಡೋಣ ನೆಕ್ಸ್ಟ್ at what time 1:40 what time is it too much time or little short let's limit 1:30 no 1:40 ಊಟ ಇದೆ ಹಾಸ್ಟೆಲ್ ಅಲ್ಲಿ ಖುಷಿ ಇಲ್ಲ ಮೇಡಮ್